Hello, good morning, everyone. Welcome to day 2 of the Oracle Summit. It's been a really long week, so kudos to you guys for turning up bright and early. We've got another day of deep dives into Oracle use cases and developments. You have the program with you. If you don't have it, there's more at the registration table. But first, I'd just like to inform you of some changes in the program that you see. So Shamil Khalilov and Alberto Melon, who were supposed to present later, are unfortunately unable to make it. But if anyone has any questions about their topics, they are both open to answering them remotely, so just let me know. And Umar Roy from Succinct, who was unable to speak yesterday, will be here later at 5. And that's all the updates I have for you. And without further ado, I'd like to introduce our first speaker, Hart Lambert, co-founder of UMA, who will be speaking about the future of oracles is optimistic with AI. So welcome, Hart.
All right. Guys, it's been a long week. So I'm going to keep this interactive. I actually have way too many slides on here to get through in 20 minutes, and I have a nice countdown timer here. But this is actually based off a presentation or just a talk we gave internally where I go through, I added some slides to explain what UMA does, the optimistic oracle, and where we've seen traction to date. And then I do a bit of an overview of the Oracle landscape and where I think there is some need for innovation. And then I'm going to touch on where I think we're going, specifically how AI and large language models like ChatGPT, this is the spoiler, can actually help us make better blockchain oracles. So what does an oracle actually do? The thing that I keep trying to educate people on is that a blockchain oracle is not just about relaying price data onto a blockchain. I really look at an oracle as a truth machine that records truths about the world onto blockchains. And so it's a lot more than just what is the price of Bitcoin right now. It is who won the US election. It's did this deposit happen on another chain, like a cross-chain use case. It's did this governance proposal pass. It's many, many things. It's very generalized. It's a big space. And as we build more and more sophisticated smart contracts and more sophisticated applications, decentralized applications, we have more and more needs to do, to get truths, to get knowledge onto blockchains. And so, just to spell it out, like our vision is to enable any verifiable truth to be recorded on-chain trustlessly. And it really, that's the only qualification. If it can be publicly verified, we want to be able to trustlessly get it on-chain. So high-level overview, and I'm not going to go, this didn't format correctly. Oh well. So high-level overview, how an optimistic oracle works. Actually simple concept. Propose a statement as true. There is a challenge period. No one disputes it during the challenge period. It gets taken as true. That's it. If we make that path happen 99.99% of the time, it's very easy, very simple. Our only trade-off here is latency. We have to wait this challenge period. The pessimistic path, again, badly formatted here. Pessimistic path is somebody disputes the proposal. And that's supposed to be the edge case. That's supposed to be the rare event. It is the rare event in our system. And then we do a bunch of other stuff there. And at a high level, I often tell people, it's like, okay, well, think about the happy path, because that's where we live 99% of the time. The unhappy path is incredibly important, because that's what makes the whole system secure and resilient. But it is rare. And for us, the unhappy path disputes go to UMA token holders where they vote in a commit reveal scheme to come up with the truth or the best answer. A lot to talk about there, but not what I'm going to spend today talking about. Okay, so does it work? UMA as a system has been in production for over 3 years, which shocks me sometimes to think through. And it's in my opinion, and I think the opinion of others, it's actually worked pretty well. We've had on the order of 10,000 proposals to the optimistic oracle, and we've had about 50 disputed proposals. I was asked a question just before this talk about like how many of those were like real contentious disputes. I'd say like 15 or so. Some of them were just mistakes, people proposed the wrong data. But generally speaking, what we've seen is that a very small number of the actual oracle requests or the truths that have been proposed, a very small number of those actually get disputed. And right now, the system as a whole is securing over $100 million in assets, and it has been for a couple years now. Okay, so if UMA is this truth machine, what I argue, and just to go into where we have traction, what I argue we do is we help protocols decentralize. And an example use case here, Polymarket is a prediction market. They run on Polygon right now. Polymarket needs decentralized data resolution. Who won a given bet in these prediction markets? And right now, prior to using UMA, they were answering these requests in a centralized way. They literally had their own resolver that would say, A1 or B1, each bet in this prediction market. And so they used UMA to effectively decentralize that process. Across is a cross-chain bridge that our team also built. Sidebar, Across is highly performant. We are really kicking ass right now in terms of our costs are the lowest, our fill times are the fastest, and our overall volume is up and to the right. So we've been very happy with how that product works. But Across works optimistically. And the way Across repays the relayer entities that fulfill user transactions is by optimistically verifying all of these repayment instructions. So again, UMA here sits as this intermediary that takes a protocol and actually helps it decentralize its infrastructure. By the way, this is not dissimilar to what Uniswap is doing with Uniswap X. Their cross-chain design too. Uniswap X is also built optimistically. And again, I look at that as sort of supporting the design decisions that we've made. Snapshot. So there's also a Snapshot. There's an UMA integration for Snapshot that follows the innovation of SafeSnap and what Reality did, where you take a snapshot vote and you, in a decentralized way, actually execute it in a Gnosis safe. So generally speaking, I look at like what UMA is doing here and where we've seen traction is you take a protocol that has a centralized thing they're doing or that they would want to do in a centralized way, and we insert this optimistic verification module in the middle to decentralize it. And this is how, generally speaking, we're looking at pushing UMA and its use cases going forward. Summarizing this, solve a centralization pain point. Okay. So where can we use this optimistic oracle? And I honestly, this is something we did internally a couple months ago, but just to give an overview of the oracle landscape. And I want to do this within this group because I actually think it's useful to highlight how much work we have to do when it comes to building better oracles. So there's many ways in slice dice to space, but I really look at them as being like 5-ish use cases that we need oracles today or in the nearest future. And it's price feed data, cross-chain verification, what I'll call arbitrary or long-tail data, arbitrary computation, and dispute resolution. And I'm going to relatively quickly flip through these. So oracles for price feed data, I mean, the elephant in the room is Chainlink, but MakerDAO and now Chronicle also have a lot of use. there's many critiques people have with price feed oracles. They're a lot of people disagree with the design decisions and the fact that they're relatively permissioned or there's ways in which they could break. I actually share some of those concerns too. But this is far and away the biggest use case of oracles in blockchain systems today. My argument is that this won't be the biggest use case in X years, where X is 2, 3, 5, not sure. But I don't think we are just building financial. We're not going to be just building financial applications on blockchain systems. We're going to be building much more. And my reminder here is, I think particularly recently, there are actually a lot of critiques around price feed oracles. Dan Elitzer put out a pretty major narrative around how DeFi protocols should be designed to not even use oracles, what he's calling oracle-free designs. And he did this because the hacks and the manipulations of price feed oracles have been so extreme, he doesn't think you can really build a credible, or call it global scale, financial application with them. I don't actually agree with Dan on this. I think there are solutions. But my broader point here is that the design space is not solved yet. And there's a lot of work to do to actually make this better. Well, back here, I don't actually think optimistic oracles like UMA work that well for this use case. This is not where we're focused. Cross-chain data, another oracle use case. There are some cool solutions out there. I'd also argue that a lot of solutions default to pretty insecure, like multi-sig-like setups. Layer 0 has an interesting framework where they let you pick your own security parameters, but many of those security parameters, the defaults, really resemble like a 2 of 2 multi-sig. And I just think that is like kind of an unacceptable security setup for the long term, at least. A lot of people think zero-knowledge solutions will be the future of cross-chain communication. I'm unconvinced because zero-knowledge solutions still aren't particularly fast. There's some technical issues as why they might not work for all rollups. I think they can actually be maybe quite complementary to optimistic designs. And here's where also Uniswap X is actually, they researched the space far and broad, and they landed on an optimistic design, which I think is quite telling. So, okay, there's some future here. Oracles for long tail or arbitrary data. This would be use cases like prediction markets or like parametric insurance. Here's where I think UMA is actually doing relatively well. We support Polymarket for now a couple years. And although there have been some controversies around how a market is written, I'd make an argument that I think the system has resolved appropriately many times, or all the time. I think this is an emerging use case of what I'm going to call like arbitrary computation, where you do some complexity off-chain, and you need to bring that data on-chain. Across the cross-chain bridge we built sort of falls in this use case too, where across we're validating a bunch of repayment things in a kind of complicated package, but we're validating that optimistically. And I think there's use cases here as more and more projects want to use Web 2 data or do complex things efficiently on blockchains. I think this is going to be a growing area as well. And then lastly, there's like oracles for dispute resolution. And this is a case where I think Kleros is the leader here in anything that's subjective at all. UMA does not have any interest in building subjective court-like systems. However, sometimes even simple things end up seeming controversial. So just the way I always look at this is UMA is trying to verify objective things, but sometimes those objective things have edge cases. Okay. So some of those emojis didn't load, but how well does the optimistic system work in these use cases? Doesn't work well for price feeds. does actually work okay for cross-chain data. The across bridge proves that, and the fact that Uniswap X is actually adopting the same optimistic design, quite interesting. I think optimistic systems are the only way to get arbitrary or long-tail data onto a blockchain. I think arbitrary computation, there's promise there as well. And dispute resolution, the UMA system works well for unambiguous questions, and then Kleros is what dominates when there's subjectivity or like a court case to decide. So, okay, that's all well and good. The optimistic oracle would obviously be a better product if it were faster and cheaper and more robust. So how could we do that? Sometimes new technologies emerge that change the game. And I joke with my team, 6 months ago, if you said like AI and crypto in the same breath, it kind of was sickening. It felt like hype cycle, just buzzwordy things. But it has changed. We actually legitimately have a new toy in terms of ChatGPT and large language models that is remarkably useful. To my surprise, I did not think 6 months ago we'd be here, and I think many people agree with that. And within an optimistic oracle scenario, I actually think these LLMs could be quite useful because in essence, they can step in and perform what some of the human functions otherwise are. So specifically, in our optimistic design, we have the person that proposes the truth, and then the person that disputes it if they think it's wrong. And LLMs can't completely replace humans here, but they could certainly assist them. And perhaps that's going to let us build, faster, cheaper, and more robust oracles. So specifically, what would I be talking about here? So right now, the optimistic oracle, and like the UMA design at least, we have to pay rewards to incentivize people to propose statements, propose truths to the blockchain or to the system. If an LLM were the proposer, you pay the API cost of that LLM. Far cheaper. Cool. I'm estimating this at you go from $50 to like a half a cent. Multiple order of magnitude improvement. The other problem is that the optimistic oracle has these challenge periods because we need to give humans time to review what the data is. LLMs run on computers, they're fast. How fast? Don't know. Can we completely trust them? No. But could we use them as a first line of defense to dispute questionable data? Seems possible. So I'd argue there's like a multiple order improvement in speed there, or could be in the vast majority of cases. And then there's lastly, one critique of optimistic designs is around robustness. Like, hey, how do I know, how can I be sure that someone is actually going to dispute my data? And, it's hard to ensure that humans show up to do things. It's a lot easier to ensure that a computer ran and looked at something. So I think LLMs can help address some robustness concerns where you can be more confident that these systems really are evaluating your data and checking whether they disagree with it. So the best thing about this approach is we can just layer this in to the existing optimistic oracle that UMA has today. There's no re-architecting the system. We literally cannot change a thing and just have a disputer bot running as an LLM that is sanity checking data that's being proposed. And that's kind of cool. Just layer it in and see how well it works. And over time, we can experiment using designs like this to propose data. We can experiment with shortening challenge windows. And maybe we can experiment with other systems where the LLM functions as kind of like the first order of defense before escalating to humans to take a look. OK, so emojis didn't load, but how does it help us with these different use cases? I don't think the AIs help us with price feed data. The optimistic oracle is still too slow. I'm not convinced the AIs help us with cross-chain data either, because most of the cross-chain data you could programmatically verify without using any kind of like intelligence. But I do think LLMs help us on pretty much every dimension when it comes to solving arbitrary or long-tail use cases or verifying arbitrary computations. They just help us do those generalized things better. And then lastly, dispute resolution. I don't think this helps at all, because we actually really don't want the LLMs deciding the edge cases. I think that's where you actually really value human judgment here. So the conclusion, and I'm actually timing this OK here, the conclusion is the future of oracles is optimistic. This has been the path we've been going down for years now, and I'm actually more excited about it than ever. And I'm particularly excited that we have fun new toys like large language models to help improve the product by multiple orders of magnitude. And that is time. And thank you, guys. I'm Hal2001 on Twitter, and thank you very much.
Thank you. Thank you, Hart. Anyone have any questions for Hart? OK, no?
Thank you so much.
Thank you. And next up, we have Edmund Edgar, founder of Reality ETH, who will be presenting on subjectificratic oracles and forking ledgers. Welcome, Edmund.
OK, I'm kind of losing my voice here. I don't know if it's going to make it all the way through. You may have to imagine the second half, but I'll do what I can. So yeah, if we haven't met, I'm Edmund Edgar. I created the first smart contract oracle, Reality Keys, way back when. Now I maintain reality.eth. I'm going to be talking about the new thing we're building. But before that, I want to do kind of a lot of background and a lot of fundamentals. So I want to start just a really fundamental level. How do we secure stuff in crypto economics, right? How do we secure stuff on blockchains? When I say secure stuff, what we're doing is we want to make some rules that are going to get applied by the system, the rules that kind of the user expects. So if it's like a layer one system like Bitcoin or Ethereum, then you basically want to order transactions. You maybe want to do some execution rules. If it's an application that we're building, if it's a Bitcoin price oracle, it's got to give you the correct Bitcoin price. If it's a DAO that's supposed to fund putting flowers everywhere, then it's got to actually put flowers everywhere, and it's insecure if you can make it use its money for some other purpose. Okay, so let's look at kind of Bitcoin and Ethereum, the base layers. How are they done? One of the mechanisms is sort of voting and hash power voting and stuff like that. That's not used very much at all in base layers, and there's a reason for that, which is that it's generally horribly insecure. Voting is susceptible to bribery. In theory, you can bribe people really cheaply, even at a fraction of the value of the thing that you're stealing. And also, you often have misalignment between the people who are doing the voting and the people who are the actual target users of the system. So that's used in Ethereum for things like the block gas limit, just the capacity management of the system. It's used a little bit in Bitcoin for kind of one stage of whether you accept an upgrade, as they do soft forks, which is sort of minor voting. But it's not used very much because it's bad. What's much more robust is what we call shelling games. So what we're trying to do is everybody is trying to follow some rules that everybody else is also trying to follow. And you get rewarded if you do the same thing that everybody else is doing, and you get punished if you do something that other people aren't doing. So the classic example is in Bitcoin, everybody's trying to build on the longest chain of blocks. And if I've mined a block and I build on a shorter chain, then that's not going to get included in the chain because the next person is also trying to build on the longest chain, so they're going to ignore it. So that's going to cost me money. But this has the famous 51% attack problem, which is that if you get 51% of participants who are malicious, then they can start to apply their own rules. So the one we're worried about in Ethereum recently is what happens if 51% of stakers decide that they're going to censor blocks with Tornado Cash transactions in them. And that could be pretty bad. But there's a final layer of security which underlines all these systems. And some people, especially kind of in the Bitcoin tribes, like to pretend this isn't there, but it is. And it's part of it, and it's what really underpins the security of base layers. And that's what Vitalik calls subjectivocracy. And I'll give you a link at the end to read Vitalik's piece on subjectivocracy, which is really good. If we look at this case where, for example, stakers of Ethereum might try to censor transactions in Ethereum, or to censor blocks containing those transactions, what we could do is we could simply follow a chain in which they were no longer stakers. Right? We can do what we call social slashing, delete their stake. We subjectively say, this is the chain that we want to follow. We don't care what your rules say. We're going to follow this chain. If you had to do this all the time, it wouldn't work. There'd be no point in having a blockchain, because it would be chaos trying to coordinate. But you can do it occasionally, and it works. And it's also how Ethereum does governance upgrades, right? When you do an Ethereum upgrade, somebody publishes the software, and it has new rules, and you can follow it. And if you think it's bad, you don't have to do the upgrade. And we've had contentious cases, like with the DAO bailout fork, where we ended up with different coins. We ended up with Ethereum and Ethereum Classic. So that is really robust as a governance, as a mechanism for enforcing rules, because it doesn't rely on counting something, right? It doesn't rely on having the majority of the stake or the majority of the hash power or the majority of anything. It just relies on the users following what they want to follow. Okay. So that's base layers. That's your Ethereums, your Bitcoins. But most of us aren't building base layers. We're mostly building applications. And there it looks something more like this. We have lots and lots of voting, especially DAOs overwhelmingly using coin voting, which is terrible. We have a few very well-designed systems, things like, Kleros is one that uses shelling games. They're quite hard to build. But they do sometimes exist. And we have hardly any subjectivocracy. And that puts us in a bit of a pickle, because it's really hard to build secure systems without that backstop of subjectivocracy. You may not have to go as far as the fork. Like usually we don't have these kind of things that have caused us to need to do social slashing in Ethereum. But the fact that we can is what makes Ethereum secure. And we don't have that in the application space. And that means that you've got this economic security bound that Clement from Kleros was talking about yesterday, where you've got stuff managed by a token. The token has a certain value. If it's securing more than the value of the token, then it's profitable to whether by bribery or buying half the tokens or by whatever method, to attack the system and to break it and to steal it. And this is kind of hitting us like throughout. It's everywhere in the stuff we're building right now. So we've got a bunch of DAOs, with token voting that's horribly insecure. We've got Oracle systems that just can't escape this this fundamental limit. And it's really bad to have this security bound, because there's no way to know in the future how much you're going to be securing or what your token value is going to be. So especially if you're putting something in a long-term contract, you need to know that the system's going to be secure when it settles. But there's no way to know that. And it's going to kind of tend to get worse over time. So if you think about the valuations of a lot of these systems, the valuations of systems that we have now are nearly all based on their revenue thinking about the future, right? They're not based on the revenue and the usage that they're getting now. And the same happens with startups. Like an early stage startup will have quite a low amount of revenue compared to its valuation. But then when that future comes, we're going to be in a situation where we've got to carry all of that usage, and all that amount that you can steal is all going to be there, and the token value is only going to represent the revenue that you can actually extract from the protocol. So it's a pretty serious situation we're in, and I think it's kind of ridiculous that we've kind of got ourselves into this situation where we don't we have this mechanism, the subject tracing mechanism, that works on the base layer, but it doesn't work for our applications. And the result is that we've got much less security than we could have for applications, and it's much harder to build applications than it should be. So we shouldn't have this problem because the blockchain isn't real, right? The blockchain is something we made up. It's our model of reality. So we shouldn't be putting ourselves in this corner where we won't allow our blockchain to model reality correctly, or where we could all see that something's gone horribly wrong. You've got a lot of people using a system with a shelling game or something that's been attacked. It's a big public attack. We can all see it's happened, but there's nothing we can do about it because we're building on a layer that doesn't have subjectivity. Now, I said earlier that you hardly ever see subjectivity in the application layer. You do see a little bit. I mean, one thing you can do, they did this with ENS, is you can deploy a contract, and then when you want to change it, you can deploy a new contract, and people can use the new contract. So we can do that with oracles. You could, if you had an attack on your shelling game system, you could deploy a new version of the oracle, and maybe you could save some of your token holders. But the people who are calling that oracle are still screwed, right? So the way we want to build things is we want to have a lot of separate contracts that all talk to each other. So it's no good to just fork one of the contracts, because all the contracts that it talks to also need to know that they need to talk to the new thing. So if we're going to get subjectivity at the level of the application, we can't do it at the level of a single contract. We've got to take an entire ecosystem and put it on a chain that we can fork. Right? Now, that may sound like kind of a bold proposition that we're going to, we've got all these deployed contracts already on Ethereum, and we're going to start putting them on a new ledger. But that's the Ethereum scaling roadmap, right? So the old Ethereum was we would have one layer with lots of contracts talking to each other on that layer. The new Ethereum looks more like this. We've got a couple of different rollups. Each rollup contract lives on layer 1. That has a state root, which contains kind of a commitment to all of the data on the layer 2 system, which is where the contracts live. So we can do something like that. Instead of a regular rollup, we're going to make a forkable rollup. It's going to look just the same as a normal rollup until you pay it a lot of money. And when you pay it an ungodly amount of money, it's going to fork. We're going to have 2 versions of the entire ledger, 2 versions of the entire layer 2 ledger. On one of them, we've got a commitment to one decision, and on another, we've got a commitment to another decision. So let me take you through kind of an actual example. I'm going to do this with Reality ETH, which I maintain, but this part could be done with another oracle, but using the same kind of fallback dispute resolution mechanism. So let's imagine that I've insured my goat against getting sick, so I can pay the vet bills. When we come to settle that, I'm going to try and make a claim. The insurance contract's going to send a message to reality.eth. And then somebody can answer the question. When they answer it, they're going to put in a bond. The way Reality ETH works, somebody can then come in and challenge that. So it's similar to the UMA thing you just heard, except it keeps going in our case with Reality ETH. So then Alice can come in and switch it back, and we can go backwards and forwards. It has to double every time, so it escalates and escalates and escalates. And then you finally get to a point where somebody pays a fixed fee to an arbitration contract. And the most common one that people use right now for this is Kleros, which you may have heard about yesterday, which is this kind of internet court system, dispute resolution system. So that's all good, but OK, what happens if Kleros is attacked? Because Kleros has an economic security bound. That's where the new part comes in. What we can do is, this time we're going to dispute the arbitrator. We're going to say they got hacked. People can start putting in bonds. If there's only one bond, maybe we finish right away, but that could keep going. People can keep escalating. People putting more and more money in the game. And you can, by the way, you can change these participants. It doesn't have to be the same person all the time. So if the early participants ran out of money, maybe somebody doesn't care about the goat and they don't care that much about Kleros, but they can see that somebody is making a false claim, so they can make some money by rejecting it and putting up a higher bond. So we keep going until somebody pays a large amount of money to do arbitration by fork. At that point, we're going to split the system into 2, and there we go. Okay. So what that's done is it's given us it's kind of freed us from this economic security bound. We can choose which ledger we're going to use. Anyone can choose which ledger they want to use. So there's no amount of voting, no amount of money that can allow a malicious person to take over this system. It's a layer 2 with a layer 0, right? It's socially people using the system that they want to use, and there's no amount of money that you can use to bribe it or twist it. We also allow you, since it's a layer 2, it can also talk to the layer 1. So it's possible to bridge assets from the layer 1 to the layer 2. You can like lock ETH up in layer 1 and then move them across to layer 2. But when you do that, those assets are going to tend to be subject to the same kind of economic bond, security bond, because they're at some point going to have to decide somehow which of these fork chains they're going to honor. So it gives you this kind of infinite security bound for assets you issue on the ledger. Okay, so that's what we're building right now. We're prototyping this on zk-EVM, but I also really like zk-Sync, and I'm kind of Tyco curious. Anyone else, please, show me your layer 2 system. I'll put up this link. Has a little bit more design detail. You can read a little bit more about what we're doing to how the bridging of assets works. And there's also a link to an ETH research post by Alex, who's here, about how stable coins can be built to handle forking better if it happens. So this is obviously relevant to us if you want to build a stable coin on this ledger, but also relevant to stable coins that you may build on Ethereum, because Ethereum may fork. Okay, so I hope that's interesting, and see if anyone's got any questions.
Thank you, Edmund. And yes, any questions? No? Okay, no questions right now. But of course, you can catch Edmund outside as well if you'd like to speak to him. Thank you. And next up, we have Brenda Loya, founder of Teller, who will be presenting on making a decentralized consumer price index. So she's getting mic'd up right now, and she'll be up in about 2 minutes.
Hi, everybody. So yeah, I know this seems like quite a different topic than one we've been discussing, but I think it's really important to not get just caught up on what we've been doing up to now, which is basically our jobs as oracles, providing off-chain data on-chain and trying to provide it as securely as possible. The way that I see the system work, and we've discussed like oracles and some confusion of what is the oracle and which portions, I guess, or how you can break it up into different ways of I guess, attack vectors and just how it functions. So in my mind, this is basically how oracles work. We focus on the architecture, on-chain and off-chain, and trying to make it as secure as possible for our users. Our users, however, they are the most well-equipped to provide us the definition of the type of data that they need, just like they are the best equipped to tell us how often they need it and all that information. So they should be more responsible for the data definition that they choose. As oracles, it's, I think, our job to advise them to use robust methods and then help them get that methodology out there so that you can do some aggregations off-chain, and then make sure that it's completely, at least for Teller, it has to be completely open and available to everybody so that anybody can come and dispute the validity of it and actually fact-check that that information is correct during the optimistic period or during the dispute period. And so this is what we've been focusing on, right? Just making the architecture and helping the users understand what is robust. What I'm proposing with this CPI thing is that we extend our reach to actually take traditional data and look at the efficiencies and benefits of blockchains and apply it to them. In the case of the CPI, I think it's super important to have some transparency for it. And open networks allow us to do this in a way that it keeps the privacy of the people providing the data that we could use to create this. So with that said, shifting the focus from to being just data providers and becoming data creators on-chain for things that can possibly be done on-chain. So the CPI, I chose this as being like the first use case for us because it is so broadly used by governments to directly affect what happens in your home. Basically, they create and change policies based on this number. They adjust government assistance programs for people under the poverty line. They might also adjust your tax levels, by the way, if you're on the other end of the spectrum. And it's also widely used for price escalation contracts, whether it's for wages, for your contracts, if you're working somewhere, if you work for the government. A lot of people are adjusted on a yearly basis based on the CPI, just like benefits for retirees and things like that. And it's used very, very, very widely for wage disputes between labor unions and, and companies. So it has a very direct effect on people. And there's a lot of criticisms that people have come up over the years. And yes, the methodology is not perfect. There's substitution bias. And that's basically, people argue that within the basket of goods that you consume every day, when things get tight, you just buy some of the, or more of the things that are a little bit cheaper in your basket than the things that you would buy normally. So the CPI is overestimated, I guess. So that's one of the criticisms. Another one is because the government chooses a basket of goods at some point in time and then tracks it over time, it lags in being able to include new things that people start substituting within their basket of goods. And then the way that it treats quality changes in the actual things that you buy in your basket. So maybe your tomatoes are not as good, I don't know. But things like that. Those actually for quality changes is mostly for technology, and there are some methods that the government uses, to adjust for this, like hedonic models, where they break down computers into its components, and then they try to assign value to each of the things, and try and just control for the one thing that actually changed in price based on a technological innovation, and they adjust for that so that they don't include it into just inflation, because that wouldn't be inflation. And those are known criticisms of CPI, and I think that a lot of people in the space, I think there's Truflation that try to address this, and there's other private companies that have tried to address this through either increasing the frequency of collecting data and also recalculating the index. And I think, yes, we can improve this, but in our industry or as open networks, this is not where we can bring in the efficiency that it needs or the improvements that we can actually provide. There's a lot of economists out there. My background is actually in economics, and I feel really, really strongly about doing this. Because of that, I think it's very important. But anyway, what I think we should be focusing on is the fact that blockchains can actually bring in transparency. So one of the things that we cannot do with government data is actually go back and fact check it. We don't have access to it, bottom line. And it's okay, if they're collecting all of this survey information, you don't want your neighbors to know that you're having a tough time with, money. And that's perfectly fine. The government protects people's privacy, and also if you're a business, you don't want other businesses to know that you have a competitive advantage or disadvantage. So that's completely understandable. But the blockchain does allow us some level of privacy protection that we can apply to this measure and actually be able to create something that maybe will not replace the CPI, but it will allow the people to actually fact check it and make sure, or attempt at least, to rein in their government's economic policies so that in the long term they don't end up paying for mismanagement. So just like crypto and cryptocurrencies allow people to basically reduce their risk exposure to their government's fiat system or mismanagement thereof, then we can create this type of measures that can provide people, before they have to go to election and attempt to take the government out, actually start thinking about how the government is affecting their life, or they will be affecting their lives very quickly. So, and this may not seem like a big deal, especially if you're from a developed country. But in developing countries, and this can be a big deal. Venezuela, nobody really trusts their government. Their fiat system is pretty much broken. Their inflation numbers are not really trustworthy. And Argentina is a very unique case because they're an open economy. They're not a war-torn zone. And yet, from 2007 to 2015, the government openly admitted to just literally cooking the numbers. And Alberto Caballo, he went back and did a bunch of research to try and recreate that period. And he ended up they thought they used this, super high, tech scheme to try and change the numbers, but it just divided the inflation by 3. They just reported a third of the inflation. And either way, they went on with making policies that affected the people and that still affect them to this day based on whatever numbers they were cooking, because they were obviously not reflecting the economy as it was. Currently, in May 2023, the inflation of Argentina, they went back, they corrected their methodology, they're now publishing correct rates. Their inflation rate is 109%. And not too long ago, I was complaining about mortgage rates in the US going to 7%. Their interest rate is 97%. That is crazy. I mean, who takes a loan that way? And on top of that, they have now caps on how much USD they can get their hands on. And also, they have an official US rate that obviously means nothing, because the black market rate, really. And as much as they have actually improved on their methodology, you can't really measure this, or people are not as willing to report on black markets to the government, right? Hey, yeah, no. They still do a survey on it, and they report on it. And if you go to Argentina, I can tell you from first experience, you will get probably double the exchange rate if you just take dollars straight in there. And it's crazy to see this, that it's happening right now. This is not from the 1960s, the 70s, the 80s, 2023. This is last month. This is just a publication from 2015 where people, obviously people didn't believe the government. We are smart enough to sort of realize that inflation is, higher when we're the ones experiencing it. But either way, I went on doing this until 2015, and in 2016, Alberto Caballo and Manuel Bertolo, they went back and then they try and recreated all of this. So they recreated this using scrape data from the major online retailers, and then they use some weighting mechanism based on old government weights and some data, because for any survey, the most important things that you have to do to actually have an estimate that approaches the population, you have to have a representative sample, you have to be able to collect the data. And then once you collect the data, you can adjust, if you didn't get enough of a response rate, and you can adjust for different outlier detection for anything that was misreported or just misunderstood. And then you kind of clean up the data, you weigh it, you classify it, you make sure that it's in the correct classification, because that's how you weigh things. Once you weigh it, you can actually approximate the population. So this can be done. They did it using a lot of scraped data, and I think that we can do it. And the only problem with what they did is they went off and did it, but they don't actually publish the data. So we can actually go back and double check it. Now they run price stats, which is under a paywall, And so that really gives us no real insight on the data. And also it doesn't, we just trust their methodology. It's like we're back to square one. So going back to why we can do it on the blockchain, we can actually, with the improvements that we have done on privacy, we can, on CK stuff and like privacy on the blockchain, we can provide that just simply like, even with CK stuff, like nothing is linked to me, right? That's why we have ETH addresses or an address on whatever chain you transact. And data transparency is literally the pillar of blockchain. And then methodology transparency, it can either be done through a peer-to-peer network, or if CK proofs get to the point where we can actually load up like that information, at the end of the day, it's just sort of like providing that so that anybody else can go and verify that what you created with this open data matches. But they can take the open data and come up with better methodology and maybe, apply whatever outlier detection system they want. But at the end of the day, you can at least double check it and take that information from any country or for any geographical region and actually be able to compare and hold your governments hopefully at least accountable, at least when you vote. But if it's before, there's right now Kenya is going through and it could be completely politically motivated, but there's riots right now because, like last week on Wednesday, I was listening to the news. Riots have broken out because they took an IMF loan. They required them to increase the tax rate, and the people are already complaining about inflation being too high, where inflation is being reported at 7%, and then there's riots. So something doesn't add up. And if we had a transparent measure, we could actually go and say, like, okay, well, this is completely politically motivated. It seems like this their inflation rate, their official inflation rate, actually reflects what's going on the grounds. But like, who breaks that? Like, I feel like unless people are really pushed, you don't go and like into riot mode. Like, that's not normal or natural. But with that said, it does, creating this on an open blockchain or an open peer-to-peer system even, it's gonna be a difficult thing to pull off. I realize that, but I think it's important. These are the numbers or the type of the amount of information at least the US government collects for the CPI on a monthly basis. And they collect it on a monthly basis. Obviously, they don't share it, but I want to say every quarter, they do go back and look and take the microdata, do some obscuring, I guess, anonymity, noise adding to the data, and then they make all the information for the actual users or the microdata sort of obscure, and then they do publish some of the microdata. So it lives out on an open web. We could collect that type of information. We could do just the same scheme with data scraping to actually be able to collect this type of information. It is a lot of information. Peer-to-peer network, like with the way that I'm seeing or the way that I'm thinking about this, and I don't claim that I have this figured out on how to do it in an open network, but I'm thinking, something like IPFS or some other peer-to-peer network that can actually house this amount of data, and then just pushing aggregate indexes with the proof that that's the data that it was used, and then or just but make it publicly available. That's like the primary thing that we need. That I think this needs to have. That this is the primary thing that we need to do in order for this to work. So this is what I've been working on for the last few months. But the ideal situation is like actually be able to collect microdata and survey people directly on a blockchain. It doesn't have to be as secure as other blockchains, and there could be economic incentives, but it doesn't have to be as secure because at the end of the day, you're gonna have to apply a lot of outlier detection anyway. Just in general, the government, that's half of the reason why the CPI only comes out once a month, and it doesn't come out as often as most people would like to. It's because cleaning up the data is hard, and people don't always respond correctly, and they also are not punctual. There's has to be a cutoff date, and sometimes what ends up happening is there's a cutoff date, and then people report for some of the data, and then it just keeps trickling in for the previous time frame. But ideally, this could be done with, hopefully in the future, in a more decentralized way, and that is transparent. And then in terms of methodology, what I am leaning towards is the same methodology that Caballo used for Argentina and Venezuela. And that's just because they just used open information and they were still able to approximate the population. But the IMF, the World Bank, and PriceStats, they all have their methodology out there for us to look at. And once we have enough data collected, and some of the way that I feel that we can use oracles is basically incentivizing their data reporters through rewards. Although this could be, it's kind of hard to think about this in terms of paying a lot of money because it seems like a public good. But you can incentivize them to create these scrapers through rewards. And then once we actually have the data in, we can actually go back and do simulations and try and figure out which methodology actually works best. We would want to sort of choose one methodology so that we can actually compare across countries. Otherwise, you can't really compare. And that's it. That's what I've been working on for the last few months. My background is in economics, and I think that we can really leverage open networks to bring transparency and oversight to governments, and just in general, sort of giving back the people the ability to do this without waiting till there's a voting period to be able to do something about it, and be more vocal about their government's regulations and changes in policies, because at the end of the day, inflation doesn't wait for the government to get reelected. Inflation is going to hit us. I'm sure you guys have felt it. And it seems right now it's claimed that it's going down, but it's going to take a long time for things to go back to normal. And for us, it may not matter. This type of economic or statistic earthquakes don't happen in most countries, but they can happen. And Argentina is not a war-torn zone. It's nothing. It could happen to our countries too. So I think it's important. Now I ran out of time.
Thank you, Brenda. And does anyone have any questions at all for Brenda? Yes.
Thanks, Brenda. That was a really good talk. I just wanted to get some clarity on, I think these are maybe 3 questions. Are you building an Oracle solution for yourself? Or are you looking for an Oracle solution?
So, yeah.
And do you have funding?
I don't have funding, but I do have an Oracle. So my first thought for this is creating the data scrapers is what's more expensive. And currently, the governments collect information from people for free. It's completely voluntary. And in the 1940s, they actually were able to rally up housewives mostly to go and double check on price caps that they had put on different meat and stuff like that. So I feel like I could potentially rally some people just for free and try and see if we can get some data scrapers going. I know I know they exist because they're used by PriceStats, maybe some by Truflation that are not publicly available. But no, I don't have any funding. If you want to fund me, if you want to post some payments on chain once this is up and running, and there are some data scrapers, and incentivize them to put them on, that's basically what I maybe I'll bootstrap it myself, but it's just because I think it's important. Yeah.
Any other questions? Okay then. Thank you. Thank you, Brenda. And yes, right now we'll break for half an hour and we'll meet back here at 11:15 for Oleg's talk on combining ZK proofs with Oracle. So see you back here. Okay, I hope that was a good break for everyone. And yeah, up next we have Oleg Lodigansky from iExec, who will be speaking on combining ZK proofs with oracles to provide confidential data to smart contracts. Oleg, everyone.
Thank you. Thank you. Okay, great. So my name is Oleg Lodigansky. I'm CTO of iExec Blockchain Technology, a company based in France where we develop products that permit to create, share, and monetize digital assets based on our twofold value proposition, governance, thanks to the blockchain, and privacy, thanks to confidential computing. And today we will focus on privacy, and I will present you 2 ways to create privacy-preserving oracles. So as you may all know, an oracle is a way to gather data, off-chain data outside of the blockchain, and to bring them on-chain. And the question here is, how can we bring on-chain private data, sensitive data, confidential data, while preserving confidentiality? So before we answer this question, before we see 2 workflows to do so, to write sensitive data on-chain while preserving their confidentiality, maybe we would like to know, to understand why we would like to do that. Why would we like to push some private and confidential data on-chain, where the blockchain is, by essence, of course, transparent and public? So there are a lot of different use cases. You can think of medical data processing, so that maybe you would be engaged to process some, to give some information of your own medical data, but I mean, without revealing the detail of your data. Maybe you don't want to reveal, I don't know, something like your blood pressure on-chain, because you could be afraid that an insurance company could modulate the price regarding to your blood pressure, for example. So there may be use cases where you would like to write on-chain a proof that you are well-being. I mean, your blood pressure is good, but not revealing the detail of your blood pressure. There are other use cases where a company would like to share some sensitive data to gain access to a new type of data without revealing their detail of their own business, for example. But merging different data from different, even competitors, could gain access to a new kind of information without revealing the detail of the competitive information of each company. And also, another use case we are working on is that KYC. I mean, identity check. So that usually people, maybe people don't want to share their information, their names, their I don't know, the color of their eyes or what they want. And not only, the question is not only if individuals would like to do that, because you can discuss that people usually, a lot of people think that they have nothing to hide, but hiding such information could help company which needs to make a KYC. This company must be GDPR compliant. So we could help being GDPR compliant by stocking on-chain some information that the KYC has been done without revealing any detailed information about the identity of the individual or the client or what they want. Something that is very funny, I always like to mention that a lot of people think they have nothing to hide, but if you think about it, nobody stores any information online about their own bank account. Nobody gives any detail of the bank account. They give detail about who they are, what holidays, where they go for their holiday, what cars they buy, or things like that. But nobody never display any detailed information of their bank account. And the notion of privacy is something that people don't, maybe are not aware about that, but people use privacy-preserving techniques every day. If you use your credit card, you never say, hey, here's my bank account, the detail, look what I earn, look what I have in my bank account. No, of course not, you don't do that. Nobody does that. The credit card permits to pretend, to prove that you can pay something without revealing any detail of your bank account. And this is the idea of privacy preserving. So even people who think who do display all detail of their life, never details any information of their bank account, and they do that in their everyday life. So privacy preserving is finally something very popular, even if people don't realize they use such technology in their everyday life. So here we will see two workflow, two technology to write on-chain some sensitive information without revealing this information. We will detail how zero-knowledge proof works. And also I would like to show you the advantage of using not only ZK, but also confidential computing. And we'll see what are these two technologies. So ZK, in one word, is a way to compress computation. We can see we can make a parallel with compressing files. Okay, ZK is a way to compress computation and give a very small result somewhere that can prove that the computation has been taken. So off-chain, the ZK permit to process some data. And after, when the processing has done, ZK technology by itself permits to generate a proof that this computation has been done, and the proof is quite small and very easy to verify. In terms of CPU intensivity, it's very low. So we can write the proof, the ZK proof online, and we can check the proof online. And this check permits to certify that something has happened, but never revealed what happened off-chain. The thing there is that on-chain, you cannot have access to data source, but off-chain, the one who had access to the computation, of course, these people had access to the data source. This is the problem we saw. So we introduce confidential computing in this workflow, so that it is exactly the same. We use the ZK proof, the ZK technology, but the off-chain computation occurs in an enclave. So I'm sorry, I left TEE and not CC, but TEE stands for Trust Execution Environment, which is the Intel SGX version of confidential computing finally. It's the same. There are different, we know 3 technologies that permit confidential computing. There is Intel SGX, there is AMD SCV, and ARM Trust. There are other ways to do confidential computing, but here we, at iExec, decided to use the Silicium versions of this technology. So what happened using confidential computing? We take the data source, we run the computation in an enclave, and in an enclave, nobody is able to see what happened there. An enclave is a kind of a vault in your CPU finally, and nobody, even the administrator of the machine, nobody can see what happened inside this vault. Okay, and at iExec, we permit to use this enclave in a decentralized manner, in a distributed manner, so that anybody who has an enclave can propose the hardware finally, and you can use it remotely. And at the end, the process of the confidential computing generates, here I use attestation. I prefer to separate proof and keep this word proof for zero knowledge. And for confidential computing, we prefer to use the word attestation. But finally, it's the same mechanism. We write on-chain something that proves that something happened. And here again, on-chain, you cannot have access to the data source. This is just not possible, just like in ZK. The difference here is that the off-chain part of the computing is also uses a technology that ensures that nobody had access to the data source, except the one who was able to process it. Okay, so finally, we have seen that both technologies, both workflow permit to compute data source off-chain to create a proof of this computation. And here, only the Oracle, the confidential computing Oracle, permit to keep the confidentiality of the input data. And today, we are working to fill this gap, so that at the end we want to run the ZK Oracle process and the generation of the proof of the ZK proof inside an enclave using the confidential computing facility. And this is our next step, and I hope we will finish soon. And that is all. Thank you very much. Any question? Thank you.
Hi. Hi, everyone. Sorry. So, next up is meant to be the panel about Oracle use in stablecoins, but one of our panelists, Mark Zeller, is running a little bit late. So, we will take a little break. You guys can chit chat, and we will try to start the panel by 12 p.m. latest. Sorry about the delay, but yeah, it will happen at 12. Thank you. Okay, yeah. So just a quick update. Mark Zeller's ETA is 15 to 20 minutes, so we'll be starting sooner. Hello, everyone. So sorry about that, the little delay, but our panelists are now all ready. So please welcome everyone on board for the panel on Oracle use in stablecoins and their challenges. One thing though, we did announce that Phil Kelly would be moderating, but he is unwell. But Nadeem from Mental Labs has very kindly agreed to jump in at the last minute. So yeah, please welcome our panelists and moderator on stage.
Yeah, hello everyone. As Pavina said, I'm Nadeem. I'm part of Mentor Labs. We are on Cello and we have been building stables since 2020, also our own Oracle, so there is some knowledge. But yeah, let's first introduce the people on the panel. Maybe you want to start?
Sure. So I'm Jacob. I'm the founder of Redstone, and we are an Oracle providing data on various assets, not only the price data, and we are quite flexible, like how can you consume assets? Could be like pool model, on demand, classic model, etc.
Hi, everybody. My name is Taylor from Reserve. Reserve is an open platform for creating stablecoins, and we're a consumer of oracles.
Hi, everyone. My name is Melina. I lead communications for HyperOracle. We're a ZK Oracle network for mainly off-chain computation.
I'm Chris Hermida. I'm one of the co-founders of Switchboard. We're a customizable Oracle network on a number of different chains. And before then, I actually used to work at Circle, so relevant and very familiar with stablecoins.
And hello everyone, I'm Mark from the Aave Chain Initiative. We are the main Aave DAO delegate platform, and we are actually the clients of the Oracle solution with the Aave protocol. We are deployed in 7 different networks, working historically with Chainlink, but also expanding to other Oracle solutions, like very recently Redstone produced a price feed for Go, our new stablecoin, and I think that's part of the topics today.
Yeah, maybe to start, we could touch a bit on the different stablecoin setups and maybe the different Oracle setups, how they are used in relation to each other. Who wants to pick it up?
I can pick it up if you want. So obviously, and I think you can add to that, there's like decentralized, algorithmic, and over-collateralized CDB-based stablecoins. So Go, for example, DAI, for example, are over-collateralized CDB-based stablecoins. So when you produce a price feed on those assets, what you want to track is the secondary liquidity most of the time. So all liquid is your asset on Curve, on Balancer, on Stable Swap. When you have like centralized stablecoins, it's actually very interesting for a liquidity protocol to ask yourself the question, how should you define the value of the stablecoin? Because you have a primary and a secondary market. So if I have $1,000 and an account at Circle, I can send a $1,000 wire transfer and get almost 1,000 USDC, because obviously there's a small mint and burn fee. And that's my primary market price of USDC, which is very close to $1. Should I care about the secondary market if I have those conditions?
Yeah, I like to separate them between stablecoins backed by real-world assets. USDCs obviously and USDT are sort of the biggest ones, but also to an extent, right, Maker is moving in that direction, and many others, and non-RWA backed ones, whether that's Go with Aave and many others.
But that's where like the line get blurry, because there's many real-world assets behind DAI and maybe Go in the future. So what's completely on-chain asset and what's completely off-chain asset? I think the lines are getting blurrier and blurrier in the ecosystem.
Yeah, one thing that's interesting is that pretty much every stablecoin, I think I can say every stablecoin, though I'm welcome to find counterexamples here, every stablecoin that is built on-chain off of other on-chain pieces does need an oracle, right? Even Rye or Liquidity, as you mentioned, still uses the ETHUSD oracle in order to know when to do liquidations and so on. So, you know, the only stablecoins that are immune from this are the off-chain stablecoins, like you discussed, USDC, USDT.
Yeah, I think that's a funny comment because like there's this race for building a decentralized stablecoin, but if you look at it, all fiat referencing stables, they need an oracle, and the input is always a centralized price. It comes from a place that is able to do fiat price making. So
if I may follow on Mark's question, this was, I think, crucial for any oracle provider. Like, why do we exist? If, for example, with Circle, you got this guarantee that you can redeem this almost to $1. But still, in our view, let's say the mission for Oracle is just to satisfy the needs of a protocol. So for a protocol like Aave, the most important question is whether they will be able to liquidate the collateral. So that's the main function for the Oracle price. So sourcing the price on-chain, when you can quickly liquidate the collateral, seems to be, let's say, the most useful price discovery mechanism for the lending protocols. Obviously, it may work different for some kind of, like, say, perpetuals, options, etc. But we always need to have in mind, let's say, who is our customer and what and how the price will be used for.
yeah, it's also an interesting point. I had a discussion yesterday with the guy from Vega Protocol. They are building a derivatives market, and we were chatting about oracles. And he had an interesting take on oracles because we were chatting about, you're building an oracle, you're averaging, you're taking a median maybe. And he said, I mean, to him, coming from a derivatives side, it's not about this average. Basically, you're defining a derivative, and you say this is a derivative based on the price coming from Binance. So you're much more specific, and I think like in our general Oracle setup, we are forgetting about this. We are creating some average, some median, hoping to get some robustness. But I think in the financial world, people are much more specific about what they actually mean if they're talking about a price.
Yeah, so I think this is a great point, and we actually already have price ranges today. I think people don't realize this. You know, Chainlink, largest Oracle provider, obviously comes with this Oracle tolerance per feed, right? So for WBTC, that might be plus or minus 2%. For USDC, that might be plus or minus 0.25%. And people don't really think about what this means, right? What this means is they may have put the entry in the Oracle sometime in the past, some time has passed, and there's been some price movement, and now the price is, 15 bips different rather than the 25. They'll be required to update the Oracle, right? So what does this mean? It means the actual price out there is different than what you see in the Oracle, but not by enough that it's worth updating the Oracle. So something interesting that Reserve has done that I haven't seen anyone else do is to actually interpret the Oracle values in terms of these ranges. So we sort of take the mean provided by Chainlink, subtract the Oracle tolerance, add the Oracle tolerance, come with our own low and high estimates for the asset. And then we do all our math in terms of these ranges, right? So it's like if you're multiplying two values together, or let's say you are projecting a swap of asset A for asset B. Sort of the best case is that you sell asset A at the high price and buy asset B at the low price, but you also account for the case where you sell asset A at the low price and buy asset B at the high price. And this sort of gives you a level of robustness that you could extend if people did provide low and high estimates directly.
Yeah, exactly. And I mean, for example, what we are doing is if we feel that there is too much uncertainty, if the range is too high, like we are suspending services, whether it's like entirely. What we don't have right now is like you could think about allowing redemption or only allowing issuance depending on how the price is moving, I think.
I think that's part of the next frontier for DeFi, to have like actual circuit breakers. That's something we are actively discussing, and because we are a decentralized protocol, we do that in the open. So if you are interested in the topic, you can go to governance.aave.com and check the discussion about like the circuit breakers and the kill switch on Aave to to basically decide what you do as a liquidity protocol if volatility is outside the bounds or the Oracle the price feed output is outside of what is expected. And for now, the answer, and obviously it's not definitive, we are decentralized, so there's going to be a vote, but it range between we stop new position, so anybody can withdraw from Aave, repay their position, but nobody can deposit more and borrow more on this specific asset, to actually move the liquidation threshold up and down to limit the potential downside of a shortfall event. And that's something that is completely underutilized in DeFi, but is completely normal in traditional finance. Like in traditional financial market, when a stock price move of 25% intraday, usually the broker will say, maybe something wrong is happening, and maybe we should take a step back, hit the pause button, and assess what is going on right now.
Yeah, just to add on that, a lot of it is balancing sort of the user experience, right, of where you don't want a user inadvertently liquidated on, say, a big move, versus protocol solvency, where, okay, let's say there is a horrible hack somewhere, right, there should be liquidations triggered on that, assuming that, say, collateral isn't where it should be.
And it's all about balance, and sorry. It's all about balance, because as a protocol also, you want to protect your users, but you never know the future, obviously. And for example, on liquid staking token, it's actually even more visible than on centralized stablecoin, is that you have a primary market and you have a good vision of a primary market. So unless Lido gets hacked, if the ST ETH value that is supposed to be 1 ETH to 1 ST ETH is at 92 cents on curve for any kind of reason, as a protocol, you may have excess debt. So on paper, some positions are underwater, but you have high confidence if you know all Lido works and all redemption work and all since Shanghai Ethereum work itself, that probably in 3 days, all your position will be above a 1 L factor. So what do you do as a protocol? Do you accept temporary underwater position and excess debt at the risk that maybe you're wrong and in 3 days the situation will be worse because there's an actual problem and your excess debt become bad debt that is actually like bad things for the protocol and the users? Or do you say, no, we just hit the pause button, we don't liquidate wrongfully the users, and we let things happen?
Yeah, I have a real-world story to share about this. So one of the R tokens in the Reserve Protocol is backed by USDC during March of this year, USDC depegged. There's automatic logic built in the smart contract to detect when a token has depegged and actually select emergency backup collateral to sell the broken token for. The protocol ended up selling USDC for 95.5 cents. And in fact, looking back, we can say, well, that resulted in a loss, right? Because USDC did regain its peg, and if the protocol hadn't sold, then it would have been better off. But I think the thing you said about uncertainty is really key. You can't really do this hindsight bias thing where you look back and say, well, it was stupid to sell it at that time because, who knows? Maybe the Fed would have decided to act differently. Maybe there was a backing in other banks other than SVB that we didn't know about, such that USDC maybe could have taken a 20, 30% haircut. So yeah, it's really hard. You have to make decisions given the information you have at the time, and it's all about coming up with good rules that over time, as you replay over and over, you're fairly sure that your protocol won't get wiped out, right?
Yeah, and one thing that I think all of this is really bringing up is the distinction between sort of, let's call it mark price, right? What is the price in the market? And sort of fair value price, right? What should this be worth? And those are really two different problems, and everybody takes a different approach to it. But I think that recognition is it's sort of, there are two Oracle prices, if you will, right? One is sort of what is the risk model, right? What should this be worth? And then the other one of what is this worth based off the last market price or based off what we're seeing across a number of different markets.
Yeah, I mean, maybe if I may also follow, there was a super interesting point about circuit breakers, like who can actually control this circuit breaker, like. We as an Oracle provider, we do not want to have this large red button and then suddenly decide whether we should stop providing a price or not, because it's probably not up to us. There are different protocols, different risk models. Also, it was super interesting to observed that in the real life scenario when the Luna crashed. So obviously the main price feed was stopped at a certain point, and it was stopped after people noticed on chain that there been malicious usage when some hackers were just deploying tons of Luna just to extract value through loans. But also after the price feed was stopped, there was another collateral because some of the lending protocols got the trap liquidity that couldn't liquidate it out. So having some kind of flexibility when an oracle can signal that there is something wrong with the price, as Nadim, you mentioned, some kind of a reliability score, some kind of extreme volatility conditions, and allowing protocols to, for example, stop the minting activity, but keep the liquidation or redemption activity would be like super helpful. We give the power back to the people who know most about how the protocol works.
Yeah, I mean, there's an interesting point about oracles. I think, like being working on a stable, there is this value that comes from the oracle relayers, and there is this like consensus that is built about the price. And because all of the relayers agree on the price, we think, yeah, this price is right. But there's something funny. I mean, these relayers, it's a package of software. All of the relayers are running the same. They're pulling the same API. They come to the same conclusion. And if the math behind this package is able to calculate a value, whether it's an average or a median, they will all provide this value and they will come to a consensus. But it doesn't mean that this value has truth. So I think this is why I believe, like working for a stable protocol, we need like a distinction where, or a second measure which tells us whether we can trust this value or not.
Yeah, maybe I can speak something about that. So what we're working on right now, we don't really have that fully developed yet. It's basically a way to verify the TLS signatures. So basically that would allow us, it's a little bit what Chainlink is also doing with Deco or TLS Notary, which basically helps you to verify well, the data that you're pulling from the API, and then you have a zero knowledge proof of that data. And then you can basically instantly say, boom, either the data is correct or it's not correct. So you actually wouldn't even need like several Oracle nodes. One node pulling the data would be more than enough already.
Yeah, I love that design. What I'd really like to see, and I think people have talked about this for a while, is if you imagine every Exchange API publishes a public key that it is using to sign some data in the background. It updates the public key on chain, as it, obviously you have to protect the private key off chain the right way. But if you imagine you have this signed data from every single Exchange API, you could have someone do a zero knowledge proof to prove that, all these values average out to X, they have a standard deviation of Y, and they're all signed by all the public keys that exist in all these smart contracts on chain. That's a really high level of certainty.
Yeah, and I mean, I think that, we're a few years away from it, but to me, that's sort of the end state, right, of all of crypto is sort of more economic activity moves on chain, right? People publish things directly there, and then you can read it, cryptographically prove that, okay, this source is not. But for the intermediate, I think every Oracle relies on some form of an honest majority or a trusted party. Not that people care, right? Sort of the market's already spoken that, we agree with this mechanism. But it'll be interesting to see if we do move in the future to that model, beyond just exchanges, right? Just sort of every data provider, every sort of API source.
I think there's in the case of stablecoin and real-world asset, there's something that I have not seen yet in the market, but we are more and more like of usage of people like just giving, especially MakerDAO, creating DAI out of thin air to create with credit line to third-party entity in the mid space and do a carry trade. Basically, they buy very high quality bonds, commercial papers like corporate loans and things like that. I would love an Oracle because in Europe, I don't know for the US, but in Europe we have like this open API standard where you can actually transmit data from the banking world and to have like zero knowledge proof that prove instantly every single day that there's actual money on a bank account, there's actual financial asset on a bank account, and then the Oracle prove that, and it's a proof of reserve. And if for some reason the money is not there on the bank account, instantly the credit line is removed. if we have that, that would be much more interesting and decentralized way to do real-world asset collaterals for stablecoins.
Yeah, so I think the cool thing about the TLS signatures is that you don't even need the API anymore. You can just if you can just log into the website by yourself and you have access to the data on that page, then you can just verify the data instantly with a ZKP. So
that would be so cool. Let's do that.
That's the Plaid approach, the scraping approach. Yeah, I mean, one thing that's really cool is Switchboard, so we pioneered that, but it relies on a trusted intermediary. And part of that was, okay, how can we make this more trustless, right? And one of the things we did was combine economic security with trusted enclaves, given that you do need some form of intermediary to trust the TLS signature, that request to the centralized API has not been tampered with. And so far, there's no real way around that. It's possible in the future that there are, but the way that I think this will play out is eventually you'll have, like we mentioned earlier, these sites, these API providers, cryptographically posting their data or in some provable way, period.
That would put a lot of people in the Big Four on job employment, and I think that's a good thing. Let's fire half of those dudes at KPMG or whatever.
I mean, there's one interesting thing with real-world assets. I mean, with oracles in general. I mean, we used to talk, about oracles for assets that usually have a good API. So this is why we have so many crypto oracles. Yes, you can probably onboard banking APIs, but I think already with FX data is getting more complicated because maybe some of you are familiar with the FX market. I mean, it's a very decentralized market. There's not one exchange that has an API and gives you the data. So there are different FX brokers. They all have their quotes, so bid and ask, and they have volumes. And it's actually quite complicated to pull in all these data. I mean, I just recently tried to do this for an African currency, and it has two sides. So which providers do I pick? Do I get an API? Maybe I have to do KYC. I have to pay for it. If I take a tier 1 provider, it's quite a lot of money. So there are a lot of questions around these APIs. So how can I integrate these assets? And I think right now we are only seeing oracles for APIs that are easy to access. But I think if we want to scale stables, and there's this idea of adding other currencies than USD, I think we will be running into this problem. And I'm curious how oracles are trying to solve for this.
So a lot of oracles already support different APIs. I mean, one thing that we did at Switchboard was we started from the ground up, where we want from day one to allow people to customize their APIs and use any sort of public or private API for their specific need. I think it's more market demand, right? Where the majority of DeFi is, for better or for worse, currently still focused on the financial aspects. Therefore, the vast majority are financial APIs. Maybe in the future, we'll see a lot more esoteric sort of usage. But I think at the moment, what you're seeing isn't necessarily a technical issue. It's more just a market demand issue.
Yeah, for sure. But still, if you wanted to bring in the FX providers, you will have to contact all. That's what I'm doing right now. I've been doing. It's a work that I think with most of the APIs right now, we don't have. For FX, the data is available. It's just a very different process of gathering the data. And regarding real-world assets, I think there's another interesting topic, which is some of these assets that might be interesting to turn into real-world assets and to turn into collateral for stables. They don't have APIs either. It's more like there is a claim that you are an owner. We were just talking about this, like some Brazilian debt from the government. It's written somewhere in a registry. And so do you think it's the responsibility of the oracles to make this kind of information available to the blockchain, which in this case would probably require a set of lawyers verifying that this claim is actually true, and these lawyers basically putting the information on-chain that this off-chain claim that is in a registry somewhere in a court is true? Do you see some, okay, it won't happen this year, next year, it's for the future, but could you see a future where this kind of information is brought on-chain and verified in such a hybrid way?
I think it would be of high interest. especially for issuer like MakerDAO and probably Aave at some point, to have this kind of off-chain verification that can have on-chain consequence. Because on our approach that is based on multiple Go facilitators, it makes sense to have like those kind of specific special purpose Go facilitators. So yes, I think there's going to be demand, and that's a whole untapped market in DeFi for now.
Yeah, I would maybe say it depends, of course, on like the format the data comes in. If we're talking like physical documents, it's going to be really tough. But if there is like an official website from the notary or like from the government or whatever, then you could also just easily verify that data once again with this TLS signature, and then you could also pull that data on chain as well. So that would be one way of going about it.
Yeah, I mean, it's just one thing that I'm thinking about. I mean, I know a bit about Redstone's architecture, and I mean, they're using a third data availability layer where they are kind of storing their data. And I mean, I'm not working on an Oracle protocol, but I'm imagining there could be a way where you are like digitalizing the contract, the physical contract, save it on the data layer, and then have basically someone verifying this digital version of the contract.
Yeah, absolutely. So we integrated with the Arweave chain. So all of the feeds that we collect, regardless whether they're from on-chain, off-chain exchanges, aggregators, have been persisted there. It's like a public domain. I think it's really important to actually assess the reputation of data providers. So you can look back in history, see all of the readings from, let's say, last year, to see whether the data provider was actually up to a standard, what he promised to deliver. That's a very good question, whether the TradFi or the legal documents will be put on-chain automatically. So I'd love to see it happen. Honestly, like from my experience working with lawyers, sometimes we couldn't teach them how to use the Google Docs. So I think there's like a heavy lifting needs to be done before they can push data on-chain. But yeah, so what we do also around it, so we work with one protocol. When they have published the balances of their, let's say, assets allocation every day, what's interesting what happened in between. So even traditional assets, they are slightly volatile. And like treasury bonds, ETF, etc., they can diverge within a day for something like a 20 BPS. Sometimes it's important if it's like a stable coin. So what we do is this hybrid model. When we get like a notarized or audited version, like what's the balance sheet, but we also match it with the real-time pricing of the price of the underlying assets, and that's something we deliver on chain. So I think step by step we can get to like a better assessment of what's the true value of this real-world asset that is backing the collateral.
Yeah, I mean, I'm wondering, in case of USDC, and I think we have someone who worked for Circle. Like, I mean, like from my experience, when I was trying to follow up what is the backing of USDC, you get directed to a PDF from I don't know, Deloitte or PwC, who has been auditing. I mean, I don't know. Is there any other layer of transparency that I'm not aware of that I could follow up if I want to understand what's behind?
So I can't comment on Circle, obviously, given that. But what I would say is that, to Mark's point, of open APIs and updating real-time access, that's sort of the dream that I think everybody wants to move to. But there's a variety of technical and just sort of business operation reasons why that isn't the case currently. What I would say is that I think that we will be there within the next handful of years in terms of this stuff. And when you think about sort of what crypto enables, right? You sort of have the real-time balance sheet, real-time income statement of every single sort of entity out there, right? If you do move everything on chain, you do have full activity there. And to me, that's sort of the end state, end goal. But in the short term, no.
Yeah, I mean, to me, I mean, of course, it's an opinion. I mean, I hope for a future where not every decision will be on chain, but I mean, some people have like different views of the future and what they want, but I like the analog human way of making decisions that are maybe not digital, and that actually I think it's worth having this challenge to move this decision on chain. I mean, you can have different opinions, of course, but yeah, but
I do have a different opinion. Not completely. I see what you mean, and there's merit to that, obviously. But I'm in DeFi because in DeFi, the rules of the game are the same for everyone. If you have $10, Aave will work for you on Optimism or Arbitrum because the transaction fee are a bit lower than an Ethereum mainnet. But if you have $1 million, it will be the same Aave, the same code base, and probably the interest rate you will pay on your position will be roughly the same. And I love that. I love the fact that it's very hard to negotiate, it's very hard to bribe a smart contract, and everybody is treated equally. And I think that's the part that we should cater to and maintain in terms of our ethos in the ecosystem, because that's the added value. Traditional finance works. It's finance for the rich, made by and for the rich, but it works. So if we are doing something differently, it should stay different.
No, I mean,
that doesn't mean we disagree, but I want to emphasize on that.
I think we agree a lot. I mean, I think so too. I mean, like how I would phrase it, I don't like the privileges that are given in traditional finance to specific players, and specifically intermediaries. I don't think it has to be like this. But on the other hand, I also think, and it's a bit more hidden, in crypto we are not better. Because if you look at how we design mechanisms, we are always designing our mechanism incorporating some constraints. I mean, for example, I mean, either we are considering actors that have money, have equipment, or have elite knowledge. Even proof of work, I mean, it's a funny name. I mean, this is something that only can be, like people profit from this who have equipment or who have money, like resources. So, like, and I think the reason is it's easier to define a mechanism for someone who has resources than to define a mechanism for someone who doesn't have resources. So I think this is why, like, our infrastructure and our DeFi infrastructure wants to be equitable, but in fact it's not.
Well, you know, to just expand on that, right, the market isn't equitable. You know, there is economies of scale, and there is just that implicit credit component, at least for decentralized stables, where, you know, the larger and the more successful they get, right, the more sort of implicit trust that you have in that system, whether true or not, right, and that sort of, you know, begets these sort of liquidity network effects and just overall brand and trust network effects. I don't see DeFi changing that. What, to Mark's point, though, that is special is that equal access, right, where anybody has access to that protocol. You can read it on chain, you can write on chain, you can do whatever you need to. And I think it would be really sad if we lose that in DeFi.
Yeah, this I agree with. Yeah.
And what I really like also about crypto is like reducing this information asymmetry. So leveling the playing field for, let's say, people who got like a personal connection in the financial world, got like, I don't know, privileged access to some data about what's happening with the balance sheet, and just making it publicly available to all of the public, and even to the, let's say, minority user of Aave that's got like a $10 deposit, they got access to the same information on chain like the largest LP provider. I think that's important. Also, we are biased because our business is just taking the data and putting that on chain, but I think that's an extra value in that for everyone, to democratize the access to finance.
Yeah, so we took a bit of a different route in the discussions, actually, but I mean, it's good. I mean, I wanted to get there, but I think we also wanted to talk a bit about, like, the attack vectors of the current setups, and we also wanted to talk a bit about, yeah, what you think are the largest risks right now in relation to stables, to oracles.
Yeah, so I think if people were on Twitter yesterday, they may have seen the Koenig Finance hack. We haven't talked about this side of oracles very much today, but in addition to the problem of bringing off-chain information on-chain, you also have the problem of one on-chain protocol reading another on-chain protocol. Now, you might trivially think that, well, isn't the information just there? How can this go wrong? The issue yesterday came from a new curve pool being deployed with a oracle that was somewhat untested, and this oracle had a read-only reentrancy vulnerability. Essentially what this means is that some part of the way through the execution of curve's code, you could escape execution and an attacker could take it for a period of time, maybe interact with your protocol, in this case, Conic Finance. I actually don't know if it's finance, but Conic. And when Conic goes back to look at the state of curve, it maybe comes to an incorrect conclusion about the price of these LP tokens. And in this case, the attacker was able to get something like a 4.5x price manipulation, allowing them to redeem their L tokens that they had originally flash loaned for about 3 million in profit and walk away. We're actually very fortunate that this happened at a very small scale early. To me, this is a feature, not a bug. This is what DeFi is good for. But yeah, these attack vectors are sort of specific to oracles on-chain, usually having to do with PWAPs and AMEMs. And the types of properties that you get there are very different than the properties that you have when you're reading information from off-chain, where the manipulation is more unbounded, right? If the 4 of 9 Chainlink multi-sig decides to update something and put any value in all the oracles, they can manipulate it 1,000x, 100,000x, whatever they want. So there's quite different types of attacks that you can expect from these different classes of oracles.
To me, it's amazing. And I'm not throwing shade at Conic because building DeFi is very hard. And we've seen that like in the first row for the past 3 and more years. So obviously not throwing shade, but it's amazing that in 2023, those kind of attacks still exist. But building DeFi is hard.
Yeah, so if I may also have a take on that. So sometimes we are talking to protocols about the price for derivatives like LP tokens, stake tokens, etc., and they are telling us the price is basically available on chain. So why do you want some money for the price feed? We look like scammers. The data is there, and we're asking money to provide it on chain. It's looks like super, I don't know, way to exploit protocols. But if you look deeper, like how the data is being fetched from the on-chain environment, there are different ways on the way that could happen and usually happen. So for example, like a usual flash loan manipulation of a price. And obviously you can mitigate that first, like reading the price from the off-chain context, but also using some methodology to balance the price, like the moving the exponential average to reduce the vulnerability, not only for the flash loan manipulation, but also for the multi-block manipulation. So increasing the economic cost of the manipulation through the off-chain aggregation is something very valuable. So I do not believe that in the future we totally get rid of oracles, even if all of the data is available on-chain. Sometimes you need to perform some extra calculation just to protect the protocols.
Yeah, maybe one other thing to add when it comes to possible vulnerabilities, which is more like the security standpoint that we're taking with HyperOracle, that we're kind of intending to replace like staking-based oracles with ZK oracles. So you can you can instantly verify the data, and in some cases for the oracles, you have an incentive to manipulate the data that you're delivering, just because maybe the stake you put down is the equivalent to say 10K or something like this, but maybe through the manipulation you could gain 1 million. So you're really incentivized to actually deliver the wrong data, whereas in the ZK model you could then say, well, we can verify that the data is actually correct. So I think that's another way of looking at it, and I think like that we're also not only focusing on the off-chain to on-chain, but also on-chain to off-chain, and then also off-chain computation back to on-chain. And I think that kind of, is a different way of looking at it, basically. And I hope that, or I think it might really impact how the Oracle landscape is going to look like in the coming years as well.
The thing I was going to add is just expanding on Jacob's point. I think every protocol is going to build risk modules. Many already have, but in the future they will, around the Oracle components and incorporating sort of logic around that to prevent this. And the other thing is just the biggest attacks on these sort of protocols have really in practice been price manipulation, and not even attacking sort of the Oracle integrity, if you will, right? Not the delivery mechanism, but rather the underlying sources. And that's not so much a relayer problem, right, in terms of data integrity, right? The oracles in every case pretty much have relayed data as specified by those sources. as much as just creating more resilient risk mechanisms around that and incorporating that in the design?
So this is a pretty different direction, but something that I think stablecoin protocols, and not even just stablecoin protocols, this is general to any DeFi protocol that's using an oracle. You know, as I said earlier, there are no stablecoin protocols on chain that don't have an oracle, right? But that doesn't mean that they all equally rely on oracles. You can actually, so a pattern that is currently the case, I think is bad and we should move away from, is using the USD oracle value of some asset in order to determine the issuance and redemption costs in some DeFi protocol. This is what Conic was doing and led to the issue yesterday. But there are very different sort of lines that you can draw in the sand for where you want to rely on oracles. It can be that your issuance redemption mechanisms are not a function of USD prices at all. Instead, you can sort of corner the reliance on oracles so that it's only for one particular function of your protocol. In Reserved's case, this would be the trading of tokens. And you can do something to ensure that the trading mechanism is actually mildly resistant to price manipulation. So an example here would be something like a batch auction. I can start a batch auction today with a worst case price of 0. I can say, I'm willing to sell these assets for 0. And as long as people can't fill all the blocks with empty transactions during the duration of my batch auction, I should expect that people will show up and bid up the price of the assets in that auction to whatever the fair market price is, modulo gas fees they have to pay, arb costs, etc. So yeah, there's many different ways to use oracles, and given that they're a necessary evil in DeFi protocols, you can make it so that your protocols degrade gracefully in the case that they malfunction.
And I want to emphasize that from our experience as a whole in the ecosystem, every design choice has trade-off in terms of security. So for example, for a long time, for example, Compound decided that USDC price value was $1, no matter what happened. Then something happened, and then they decide to integrate Chainlink price feed. And that was not a bad design per se. It was a design choice that led in specific condition to loss. But otherwise, it's like an interesting design. Aave, we use Chainlink price feed that will integrate data from on-chain and off-chain, so CeFi and DeFi, and globally. Not only on the chain, we are publishing price feed that allows to be more resilient to local manipulation. So if the asset price on curve goes completely bonkers, that will not be reflected in the Aave price feed of that asset, because the outlier will be killed by the medianizer of Chainlink. That has an advantage, but what happened when Phantom, something happened on multi-chain, and then you have a bunch of assets that originate from Ethereum that are unbacked with a fair value of 0. Well, your Chainlink price feed will say, there's no problem, because it's a medianizer and doesn't really consider what happened on Phantom right now, doesn't consider multi-chain right now, but consider the whole ecosystem, and yeah, USDC is completely fine and worth $1. So we got lucky on this one because Phantom market was frozen a year ago, so it was impossible to manipulate on that. But we got the Harmony situation a bit earlier, and that led to some user loss. So that's a good design choice, but also have trade-offs. And I think every single situation will have some trade-offs, and it depends as a protocol what you optimize for. But I don't think there's a silver bullet out there.
Yeah, I think there's an interesting detail between, like, if you have something like an order book, which in a way is an auction, and you have an AMM, which in most of the redemption and issuance setups requires the Oracle as an input for the center of the virtual order book. I think in case of a traditional order book, market participants, even in times of uncertainty, are able to come up with the fair price, while in an AMM setup, you need the input from somewhere. And I think this is the funny thing, and I always try to wrap my head around it, but I don't fully understand it. I have this feeling like our AMMs, they are not like completely able to be price makers. Somehow they are through arbitrage, but there's something to it which like makes them different from a traditional order book. Yeah, sorry, but yeah, what I wanted to talk about is like something about ZK proofs and the computation that you mentioned, and also like the evolution of oracles that would maybe bring more complexity. I mean, I'm not very familiar with these ZK setups, but I would love to understand how they could help to make computation, and like when you are thinking about these more complex setups, I guess computation would be more expensive, how they could help to make these computations cheaper, and also maybe like make oracles cheaper on expensive chains.
Yeah, so basically how we're doing this at HyperOracle is that you can create like a custom logic in something that we call a ZK graph. And a ZK graph is basically sort of the standard in which that then runs in our off-chain ZK VM. And that off-chain ZK VM actually runs in WASM. So basically that allows you to do a lot more different things than what you have currently in like traditional sort of ZK rollups, because they're all like ZK EVMs, so like Ethereum virtual machines. And so you're still constrained to solidity in that case. Whereas like for us, if you run like, you can basically run any computation off-chain. So it's completely arbitrary what you want to do. And then the cool thing is, because it's a ZK VM, it creates a proof of that computation, and then it puts the result and the proof back on chain, and then you can instantly verify that this computation has actually been executed in the correct way. And I mean, that's going to definitely unlock like a lot of cool new use cases. We have some people who are building in stealth a stablecoin project using that with us. I can't really speak that much about it right now, unfortunately. But yeah, I think that's going to be really cool to see going forward what people are going to build on that.
Yeah, you know, to that vein, we built switchboard functions, which really expands the design space with what you can do with an Oracle, where you can request data, run it through a risk engine, you know, run computations off-chain, and then bring that result in a verifiable way on-chain. We don't think, you know, it makes sense to necessarily separate things. If you're already putting those trust components on the Oracle for price feeds, you know, you might as well add the flexibility and freedom to run more compute and do more complex activity and custom logic with that. With the design space being less about necessarily saving gas fees and more about, in a timely manner, right, bringing the data that they need on-chain for that particular use case.
Yeah, so I am extremely excited for this technology to come live. Here's one way you could make a almost completely decentralized stablecoin, or rather a decentralized flat coin, out of this kind of technology. So imagine that we're living in a world where you know, all the assets in the world have been tokenized. There are representations of them on-chain. There are many different issuers from many different geographies for all these tokens, right? We have on-chain the information about exactly what the world economy looks like, what percentage of different assets, basically how the value is distributed across all the different assets that are held by humans and smart contracts alike, right? That information is sort of intractable to be ingested by some stablecoin protocol unless we put it through this off-chain ZK transform, where you can basically say, look, I read out all the different market cap weightings at block X, and if you do this mathematical transform, you get back this distribution of assets in these particular percentages. So a stablecoin protocol could take this and have immutable code that automatically sets the backing for a flat coin, in this case, to this distribution of assets. So essentially what you have is we could all use a token to transact that is like a little slice of the global economy, right? And while this wouldn't be inflation resistant in the short term, you know, shocks like Russia or COVID would cause price increases, this would on a medium to long term be an inflation resistant coin, because you expect it to reflect the size of the global economy. It's a bit like everybody is transacting with the thing that all the extremely rich people in the world already use to represent their wealth, which is these, you know, complex portfolios that they pay people to manage. That is actually usually expressing some sort of agnosticism about the ideal approach and actually sort of using the market to tell them what that distribution should be. So, you know, we're very close to having the technology to do this ourselves on-chain in a way that anyone can benefit.
If I may follow up on this zero-knowledge approach to oracles, like personally I admire everyone working on that. It's gigabrain and a lot of knowledge, especially the level of math to get a grasp. And we've been playing with a few few partners like on creating storage proof, which will be an amazing technology to get rid of this trusted intermediary, especially as we source more and more data on chain. So as a goal, as a direction, I totally agree. That's how we should move forward. Fortunately, at the moment, I think it's still too expensive, and I mean too expensive is just the proof generation is rather slow. So not for every use case we can get like say like a low latency data being delivered through in a proven way, and also cost-wise, like the verification of a proof on chain. So correct me if I'm wrong, but to the best estimates, it costs something like 200, 300,000 of gas in the most. In the best use case. So if we can optimize, and I believe we will, then definitely I think more and more oracles will be using the data source to approve generation mechanisms on the on-chain activities.
Okay, I try to be a bit more, pay more attention to time than I did in my talk at Stable Summit. So we are at the end. Maybe a few quick closing thoughts before we open for questions. If you have, I mean, you don't have to, but if you have something on your mind, then now is the time.
So if I may start, I think that in the future, Oracle will deliver, let's say, like a more complex data structure. So currently, we deliver the price, the spot price, single price. We try to create like a holy grail of a methodology for this single price feed, but I think it'll be more like a multi-dimensional field, so not only provide like a spot price, but also like a price, like a fair market price of liquidation of a certain amount of assets, and that's something being constantly being asked for by the customers, lending protocols. And I think if you can add some color, like what's the liquidity profile of a given asset, or if we can add more data, what's the actual, let's say, certainty level, as with stable coins, of a price, whether we should stop certain functions in the system or whether we can unpause it, etc. So more data we can deliver to protocols that makes value for them. I think we as oracles, we strive to do that.
Yeah, I'm happy to pass over my turn here. I think we already said I came with a lot of good ideas, and I don't need to waste anyone else's time.
Yeah, then it's open for questions.
Thank you, Nadeem. And yeah, does anyone have any questions for our panel?
Hi, thank you, great panel. Just wondering how you think about matching up like the attack costs of a decentralized oracle with the kind of extractable revenue on the protocols it secures, because stablecoins can be billions in market cap, but you can imagine the attack costs are a tiny fraction of that, and it seems like it's not been solved. So yeah, curious what your thoughts are.
Yeah, whoever wants, just.
Well, so I'm talking about the Aave experience on this. Doesn't mean like it's a perfect solution, and there's probably other ways to do this. But basically, it's true, and there's no way to solve that because you will not have like a one-to-one backing compared to attack cost, and as we grow, it will grow larger. So but it's true since day one of blockchain, So if you are a Bitcoin mining pool and you collude with the other guys, you can do double spending and steal Satoshi Nakamoto coins, and that's super profitable. And there's been situation where, like in Bitcoin mining, 3 mining pools could do that, but nobody's done that yet because the way we design blockchain system is that it's actually super hard to collude. So for now, it still works, for sure. So just to give context, Chainlink Medianizer works the same way. So you have like Chainlink price feed operators, and they give data, and if there's an outlier, they get slashed. So unless they successfully collude, they get slashed, and that's usually how it works.
Yeah, I think so far, what we discussed earlier about the price sort of attacks on oracles, there haven't really, been any large attacks based off the relayer model being compromised as much as manipulation of the underlying, right? What I would say is, right, in theory, every single system should be secured to some point where the risk of a particular attack for a particular block for a particular malicious point, the cost of publishing something malicious there is greater than any sort of benefit they would have by manipulating something. In practice, right, most oracles get around that by using some form of trusted majority, right, or honest economic majority, or a trusted intermediary. In some cases, both.
I just think it's a really excellent question. I'd say this is something clearly I think we don't understand right now today, and we shouldn't use the fact that there haven't been attacks of this kind against Chainlink to mean very much. It does seem like that we are backstopping this entire massive system on chain by this smaller system, and it seems like in theory it should be able to be attacked profitably, and that hasn't happened so far. For me, this is just a flag that there's something here I don't understand that's going on. I think it's a really good question.
Yeah, but do you think really you will have in the future Lido operators, rocket pool operators that will collude to attack Ethereum? Because in theory, that's the same vector of attack. And in theory, you can make a shitload of money too. But it just doesn't happen. Why? It's an honest question. Why it doesn't happen? I don't have a specific answer and set in stone answer to that.
Sorry, there's one interesting thing that you're mentioning, something that you don't understand. And there's something that I don't understand around stables. Because, in traditional finance, if you have a government bond, it's non-defaultable. If you have a corporate bond, it's defaultable. And then you have a spread between the government bond and the corporate bond, which reflects the default probability, because it's more likely that the corporate will default. Now let's look at our stables. So let's say we have USD. USD has 0 or some small default probability. We are creating a stable. The stable has a higher default probability, but where is the spread? So I'm wondering whether there is some extractable value in this, and I don't understand why we don't see this. I mean, I don't understand why all the financials are not shorting our stables, because there is a spread somewhere and we are selling it for 1. Are all the protocols paying this? I don't know.
Well, I mean, everybody's paying when they're using stables, right? You're passing on the interest that, Tether, USDC.
But even before, I mean, even when we didn't have the interest rates, it was the same. So, it's just a recent event that we have interest rates. I mean, just remember, some time before we had negative.
Right.
Yeah, the case of USD and Terra, it's sort of like this turned up to 11, right? It's like everyone knew this thing was risky, right? But it couldn't trade below $1 until it did, and then it went absolutely to 0, right? And if you shorted USD prior to that point, you probably got wiped out slowly over time. So there's this interesting way in which the local mechanisms can sort of tie you to one location, but there's this ghost price in the background that you could sort of track and sort of stat arb against, but it's kind of unclear when you're actually going to successfully exit to make your profit.
Yeah, it's scaring me, and I don't fully understand this. Yeah, is there some more questions, or the time is over?
Yeah, well, if anyone has a burning question, if not, no, it's time to break for lunch. But I mean, a good time to catch our panelists outside if you want to talk to them. I think that was a super interesting discussion. Thank you so much. And so yes, please head upstairs to the exhibition room. We have drinks, sandwiches, and we also have a roundtable discussion at 1:15. We'll be talking about Oracle and Oracle-free DeFi. And after that, 2:15, we'll be back in this room for a panel on data provenance. See you then. Hi. Yes, yes. Hello, everyone. Thank you for gathering back here. I hope you had a good lunch. So next up is our panel on ensuring data provenance in a decentralized world, moderated by Bianca Buzea, founder of DevRel University. And yeah, so welcome our panelists and moderator on stage, please.
Thank you so much. Does it work? Yeah. Thank you so much, Parvina. Hello, everyone. Thanks for joining us. I hope you had a good lunch break. So now that we're all fueled, let's discuss about the next panel, data provenance in a decentralized world. We know that it's important to take real-world data from off-chain and put it on-chain. So this data fuels some of the most important and widespread decentralized applications that we have, and is the cornerstone of DeFi. In this panel, we're gonna explore how this data gets on-chain, what are the challenges around security and scalability when it comes to bridging this data on-chain, and how data providers currently work, and most importantly, how they can improve in the future. So before we start the conversation, I suggest we do a run of intros. I'm going to start with myself. My name is Bianca Buzea. I'm the founder of DevRel Uni, where we teach people how to do developer relations. Today with me, I have Anastasia Melakrinos from Kaiko, Senior Product Manager.
So yeah, hi everyone, I'm Anastasia. I work at Kaiko, so I'm specialized in DeFi data, but I've been at Kaiko for a while now, working around any types of market data and specifically working with the Oracle ecosystem to make sure those data, specifically prices, are accessible to the on-chain world. So Kaiko is a data vendor, so we have any types of market data out there, first CeFi and now DeFi and overall blockchain data. So yeah, I'm really happy to be here.
Thanks, Anastasia. We also have Sebastian Rodriguez, VP of Product at Polygon ID.
Hi, thank you, everyone. Yeah, Product League, Polygon ID. Polygon ID is an identity layer for Web3 based on the principles of self-sovereign identity and decentralized identities. You can check more online.
And Hong Lin, the CTO of Fala Network.
Yeah, hello everyone, I'm Hang. I'm CTO and co-founder of Fala Network. So Fala Network is off-chain computation protocol. Yeah, unlike like the program deployed on the blockchain called smart contract, there are a lot of limitations. For example, you cannot access the internet. You cannot access the data available in the off-chain world. So what we can do is actually run something like a decentralized cloud with the capability to bring the data back to the blockchain. Yeah, I'm very happy to join the panel.
Thank you all for joining. So I suggest we start with an overview, and then we're gonna go deeper and look into the challenges and how we can solve those. So based on this, what would you say are the main points that we can take to ensure data integrity and authenticity when it comes to getting data from off-chain and putting it on-chain? Who wants to start?
Okay, I can start. I can talk about the data itself. So when it comes to data authenticity, well, as data vendors, what we can do is mainly make sure that our data is regulated. There are some strict regulations like SOC 2, to which we comply, and which make sure that our data is always available, because availability on-chain is really a thing. Our data is qualitative enough, and when it comes to our relationships with oracles, they're also very strict in data integrity, because They have always their own methodologies, and my answer to your question is actually, in my opinion, it's the Oracle's role to ensure that their data aggregation methodologies are good enough and strict enough for data providers to actually come and comply with what is needed from the consumers.
My turn, I guess.
Whoever wants to jump in.
Well, I'm a bit of an outsider if you think in identity, but I like to position myself as an identity oracle, and then things start making sense. The challenge that we have is to bring identity signals or identity traits of an individual to the chain, right? And the challenge when talking about bringing this information to the chain is, first of all, you need to define what is the source of trust. And then you need to carry that trust across multiple interactions and transformations without breaking it. And that is not an easy task, right? You may decide that if the source of trust is public signals, like your on-chain activity, that is quite easy because it's deterministic. But if you're trying to bring real-world signs like your social reputation or your KYC data or things like that, right? You need to find a trusted organization, and you need to ask a trusted organization to create that information, sign it, and then that needs to be passed across multiple layers without breaking that cryptography, right? To make it really, really trustless in all the way, right? Sometimes that means just using public key infrastructure. Sometimes it means to use technologies like zero knowledge to certify the execution of a certain process in a certain way, right? That you are not deviating or tampering with the information in the middle. So I would say these are the two challenges, right? Deciding who is your root of trust and then not breaking it until it gets to the blockchain.
Yeah, I think this is a very interesting question, and the other speakers already gave a very comprehensive answer. So I just add a little bit to that. So if I'm thinking about getting some data from the off-chain world to the blockchain, there are a few steps. First is that we need to make sure we have the correct data source. Sometimes it's just a single data source, but sometimes there are multiple. So yeah, in terms of the Oracle, usually we do some kind of aggregation to make sure the data will be valid on the blockchain. So it's not just from a single source of truth. Sorry, not source of truth. I think a single source. In this process, I think a typical challenge we are facing in the past is sometimes some of the data source is not like some very public available data. For example, maybe we must have some API keys to access the data from probably like from Google API or some AWS API. So when in this process, if we have multiple like reporters, how to keep the credential to access those API will be one of the problem. So yeah, just a simple adds up on that. And another point is in this process, there are two characters. One is the, we see security. One is the correctness, and another is the availability. Sometimes we call that liveness. So that means if we want to make sure the data is always available, it's not only the correctness, but we also need to ensure the system to ingest the data to the blockchain always exist. So that will involve some kind of like tokenomic to give incentivize to the participants to make sure the network is always up and running. Yeah, these are the two adds up.
I agree, and following on that, you already started to mention some of the practices, but maybe we go a bit deeper and we explore some of these best practices for taking the data from the off-chain and integrating that data into smart contracts.
Well, I can talk about the best practices. I think my case is special because we deal with private information, right? So maybe I can put the focus there and later speakers to focus on the public signals, right? In identity, we deal with private information, and that is very, very tricky when you talk to blockchain, right? Actually, private data is, from a technological point of view, is toxic, right? Because first of all, you cannot put it on chain. Second, you cannot even put things on chains that allow you to deduct private data. And then finally, when you look to storage solutions for the data, you cannot also look into decentralized storage because it's immutable, right? So I would say the first good practice is to use a lot of zero knowledge. So there are two tools that we are using extensively: the zero knowledge, Merkle trees. These kind of things are vital to make identity and private data in general work in this world. And then the other thing is to see. The key thing is who controls or who consents access to the data, right? And in that way, we are using the keys for the user as a controller of the data. That is also a good practice because you don't take responsibility on the storage, right? But again, these are good practices that we have learned because we are in that specific business of managing private data and taking it to the chain.
I totally agree. And about the good practices that I would suggest are a bit different. Those are more on the data side of things. One, I would say, is outliers management. So bad data can lead to bad consequences, very bad consequences, specifically financial speaking for the protocols that use the data in the end, and like liquidations and stuff. And one of the best practices we at Kaiko have actually put in place with the years is applying serious modeling, quantitative modeling to our price feeds to make sure that they are okay with what the ecosystem needs. So really take everything that already exists in quantitative finance and apply it in crypto data to make sure that it's really compliant with the needs and sensibility that this data has in the on-chain world, as well as monitoring, of course. I see that more and more oracles provide the monitoring of the feeds that they provide to their consumers, both on the data availability and data quality side, which is a very good thing, and I hope this will continue to be the case.
Yeah, that's pretty interesting. Yeah, and I think another, just one example come up in my mind is another type of oracle for security. So, there are a lot of cross-chain bridges, and those bridges sometimes get breached. So the recent one was the multi-chain. It was, I think, multi-million, right? So one interesting thing I've found from this case is that I think probably we can have multiple levels of security assumption. So for example, for some of the data, probably we need very low latency. So in that case, we always get the data from the oracle directly and use it directly. And recently, I learned a new concept called the optimistic oracle by Uma team. So it's really interesting to me. Optimistic oracle means that the oracle data is not just post to the blockchain and use that directly, but it's more like first they post the data to the blockchain, and then there is a game theory kicking for some time. So this kind of game theory can ensure a higher level of security. It can even be another security layer beyond only the data source. Because if anyone think, oh, this data source is incorrect, or there's anything in the link of the data, then they can point it out and jump into the game theory to try to dispute this problem. But for this kind of data, it always has a long latency. So probably it's good for the bridges to implement multiple layer security measure. For example, if the bridge amount is not that high, then we just let it go. But if it is a very high amount or reach some threshold, then the bridge can be stopped and wait for like a few hours dispute of the Oracle data. So this can ensure another layer of security for the bridges.
So Anastasia started with this, like how the measures we take to basically ensure that bad data doesn't come on chain. We know that we can have price manipulation, data manipulation. What are the risks do you see when it comes to bridging this data from the off-chain world on-chain, and how do you think we can prevent those?
Yeah. I think it's kind of like related to the things I just mentioned, but this time the price data. I think price data is the most often used data on the blockchain for nearly all the lending protocols, and we see a lot of hacks in the past just because someone manipulated the data. And I think the way to mitigate that is to diverse the data source. So a lot of data manipulation actually not come from Oracle. It comes from some on-chain data. For example, some people just use the data from like one trading pair. And those trading pair are just AMM, and it's pretty easy to use like flash loan or get some large amount of the assets to manipulate that. But if we introduce a little bit latency, like we get the data from the real world, from the Oracle, or it's an average of the data for some time, maybe a few minutes, a few hours, then this will be much harder to be manipulated. And as I mentioned, I think another approach is some kind of the second layer security guarantee. So if some transaction it results in a really large like price movement or a really large amount of the assets, then probably it can require a longer time to settle that or verify the data for a longer term. So this can be much harder to be manipulated.
To jump on what you said, which was very interesting about the number of data points we take to actually, like this number is important indeed, but something I think is also important to make sure the data is good is whether it comes, like whether the data providers that push the data on chain take already aggregated data, or it's data that comes directly from market makers or exchanges, so it's data which comes from only one source, and in that case you can have many data sources, and then the Oracle aggregates the data. And I don't have the answer on which model is better, because like there are oracles that use one model, which is like taking the data from the source. Others do like re-aggregate the data from taking the data from already aggregated sources. I don't know which one is better, still to be figured out, but I think this is something we should also think about as an ecosystem, because the results in the data quality can be really different and variable according to situations.
Yeah, I totally agree on that. So like from the practice, from my understanding, although I'm not the real expert in price data, but in my experience, multiple database has their own different security assumption. So like if you're going to make your own data source, if you can, right, then you can choose how many data sets you are going to involve, and like what is the methodology to like smooth the data or to process the data. And I think it's all applied to the different scenarios. So it really depends on the real use case.
I totally confirm, and from experience, so when we push data for example, ETH USD, it won't be aggregated the same as if we push data for a small altcoin. Because the liquidity behind is not the same, and so the outlier management that we apply to this as well as the number of data sources that we can have to push a reference data, a reference price is also not the same.
And you mentioned earlier decentralization as a mention to prevent this bad data. Why do you think we don't have a better decentralized way to put this data on chain? What prevents us from truly decentralized data on chain?
Yeah, that's a very good question. Yeah, I think decentralization is decentralization to me is a method, and it tries to solve the problem of trust. If there's only a single person to trust, then the trust is a big problem because the single person can do whatever he wants. So it's just a measure to solve the trust problem. But to solve that problem, usually we are going to involve multiple parties, not a single party. Yeah, but really it depends on it depends on how we do that. Sometimes like zero knowledge proof can also solve some of the problem. But let me just focus on the decentralization part. I think by decentralized network, for example, have multiple reporter, have multiple participants, and they join the game by put some stake into their like identity or account to make sure if something goes wrong, they're going to be slashed. So this is the game theory involved. But all those methods will have some kind of overhead or the costs. So the more the system is decentralized, the more people should involve, and the more assets will be involved, then the cost will also rise. So yeah, for the very important use cases, I would say the more decentralized, the better. But for some of the small use cases, very long tail use case, maybe just used by a simple game, it's just a single round game happening like half an hour. After this half hour, nobody care about its result. For this kind of scenario, people tend to use less decentralized and more cheaper way. So yeah, I think it's a big trade-off.
So if I hear you well, you're suggesting that, okay, for some sort of data, we use one approach. For other data that is more sensitive, or more strict with it. What do you guys think are ways in which the community can basically participate and collaborate with real-world data providers to make these data feeds more reliable and more decentralized?
I like to start with something that you said. So correctness is one aspect, right? And securing this chain of trust is something that I think cryptography can help us a lot to accomplish, to the point that is almost trustless or even trustless, right? You don't need to put the trust in the actors, but you put it in the process, right? But that said, I think this goes as far as the quantitative data. So you can say what is happening in the world without actually saying what is truly happening in the world. So if a community, and now linking this to your question, if a community decides that they want to manipulate a token, right? If there are actual professional people doing this, right? You can hire their services to pump your altcoin, right? So if a big enough community decides that they are going to manipulate the instruments that we see to interpret the world, your role as an oracle or as an identity provider is just reflect what is happening. That is what is happening, which is not really the truth or what you are looking for, right? And then is when you get into the realm of qualitative data, right? I think the next step in solving this has to come from reputation, right? It's a similar problem that we have with the content with AI, right? At some point, you cannot trust the content, and you need to rely on the reputation of the source, right? And this case is the same. So when there is an interest to manipulate the signals that we use to read our world, then we can not only rely on the signals, we need also to rely on the identities that are behind the signals.
And talking about other data, indeed, there is a need, I think, to not only rely on the price, which can reflect or not the reality, but also on the reputation of the parties that exist in the markets or on the blockchain and participate in this, but as well on other data sets. Like I've seen, like all of the oracles today, of course, provide to their consumers the price, but there are other metrics like the liquidity in the markets that determine the liquidity of a token that are really important to avoid like protocols making available for their users totally liquid tokens, and when an exploit happens, then it ends with, like, for example, bad debt or like the protocol being ruined, its reputation also being ruined. So I think there needs to be education on, I mean, we're trying as data providers to do education on which data, in addition to price data, needs to be available on-chain for specific use cases. So this can be liquidity data, this can be reputation data, this can be, I'm sure we can find many examples of data sets that could be essential for DeFi's and other protocol sustainability.
Sebastian, you mentioned regulation. With regulation also there are some challenges. How do we ensure that the data out there is basically compliant with the regulation? Because we might have additional challenges, especially when it comes to decentralizations. With data that is siloed, that's easy. Like you move the database, you move it to another region, but with decentralized data, for example, when it comes to GDPR or other policies, it's very tricky.
Well, I'm aware that this is an Oracle panel, so if you ask me about GDPR compliance, I think we can take the rest of the session just for that. So I'll answer very quickly. This is, I don't know to which point this is an Oracle thing, because it has to do with the privacy of the data. When it comes to the privacy of the data, and this is something we have researched for months, our conclusion, right or wrong, is blockchain is not a good solution for that. We can work on decentralized storage, right? But there is always something you need to give away. For example, the decentralized storage network cannot be completely permissionless. It will have to be permissioned. It cannot be immutable. You need to have proof of deletion. Right, so there's a number of things that when you put them all on the table and you look at the principles of blockchain, you will need to compromise on something, right? So far, if you are interested in that, the best solution we have found is a permissioned decentralized storage network that is governed by a layer of blockchain, so that the nodes have to prove to the blockchain that they are deleting records, that they are behaving according to the governance principles of the compliance, right? So we are using the blockchain as a policy of the database. This is the best approach that we have found so far, but it's a really complex topic.
Yeah, I would say this, yeah, indeed, it's a really complex problem. I think the community has been thinking about that for years, like how, yeah, if you interact with a smart contract on Ethereum, how you can delete that, right? It's impossible right now. So this is like a conflict between the technology and the regulation. So yeah, again, I'm not an expert on regulation, but I do think, personally, I do think both the regulation and the technology will evolve altogether. And at some point, they can probably meet each other in a harmony way. So just one example, the things we're working on is called verifiable off-chain computation. And since it's run off-chain and we use some kind of help from the hardware, so we can actually achieve some kind of privacy within the hardware. So like you can run some program, but the data in the program is not exposed to, just like the data on the blockchain directly. So yeah, this is just a simple example. So what if in the future we have better zero-knowledge proof and better multi-party computation to make sure those privacy data will never arrive on a public ledger? Then I think this is the evolve from the technology side. The evolution from the regulation side, I'm not sure, but since the blockchain technology, once it's invented, I think it's non-stoppable. So yeah, I think the world will follow this trend.
Can I add something? Sorry, because you gave me 1 point. So one piece of advice to anyone using oracles or data sources from the off-chain about private data and identities is some common misconception or mistake that we see over and over is people, a single signal about an address is probably not too bad. Like, hey, this signal is proving me that I'm over 18. Fine, let's put it on chain. This one is giving me the signal that I have passed a KYC. Let's put it on chain. It's very pragmatic, right? But the thing is, right, you keep adding these signals over time, and this is forever, which means you are enriching more and more something that was supposed to be private at any point in time. So you create enough signals that the identity can be detected or linked to the individual, then you have a big problem, right? So be careful when you start bringing these private signals, even if you think they are harmless, right? And I'll give you an example of how far we had to go to solve this, just to understand how complex the topic is. So we, in Polygon ID, you can share verified credentials in your wallet, which is basically a JSON file. You can prove your credentials to a smart contract directly. So we have on-chain verification of verified credentials, which is quite unique in the world. But the way we do that is through zero knowledge. The thing is, if you have present a zero knowledge to a smart contract that says that I live in a certain country, that is going to stay there forever, right? So we had to go as far as creating a burner identifier for every interaction, so you cannot trace and add these signals and put it under one identity, right? So the complexity of the solutions gives you an idea of the complexity of the challenge.
Yeah, I think that's a really interesting point. I even didn't think about that before. So like once people getting reveal more and more information, although it's not zero knowledge, but it's actually not 100% zero knowledge. It always leak a little bit about your underlying data. So that also remind me probably we need some kind of like the privacy setting in your iPhone or Android, right? You can have a dashboard, see what is all the data available for yourself and how you can manage those data and try to make sure you don't reveal the data you don't actually want to reveal in the future. Yeah, but that's really a big challenge, and I think that's yeah, probably a very interesting market to explore in the future.
Building on that idea, what do you guys think are some possible ways to basically incentivize people to share their data, and what are some possible models to give them something back, basically, like some rewards to make them share that data?
We have some experience at Geico with, like, since we work with many oracles with different like incentives programs, we have seen pretty much everything, and I can begin with what doesn't work. It has been very hard, for example, to work with oracles that typically give are not clear about the quantity of tokens that they give to data vendors or the value of this token specifically in such market, and which tokenomics do not seem stable. However, today most of the oracles have pretty stable tokenomics. So yeah, I suggest that I would suggest as a data provider to oracles to really like focus on the tokenomics, to really have long-term incentives for data providers to come in, because it takes much resources for data providers to actually implement as node providers on the oracle and to push data. Sometimes it requires nodes, like it's really much time. And yeah, that's my main suggestion. Some other models that work and are very like bring much incentives to data providers to do their best to participate in the Oracle and to push data, like the best data possible and in the lowest latency, are ranking systems. Some oracles use those ranking systems from the moment that they're transparent. They use those ranking systems to incentivize data providers to basically be the best. And I see more and more oracles doing this. And at Kaiko, it has been really a model that worked very well because it really pushed us to work a lot on the data quality that we provide and really improve it intensively to meet the requirements. So yeah, ranking and good tokenomics.
Yeah, let me try to answer that. So yeah, that is about the very specialized data, incentivized to the very specialized data. So this is just my personal thinking. I think, what if we can have some kind of big data or the AI-related recommendation, but it's not centralized, just owned by Google or like Facebook. So this will be very interesting because in the past, all the data available by the user is just monetized by those big tech companies, but not the user at all. But what if we can have some kind of yeah, I think it doesn't exist, but what if we can have some kind of user profile, decentralized user profile only for the user? So since it's decentralized, so the data can be owned by the user, then the user can use those data to to get some monetization for themselves. For example, you get some ads recommendation, but since those sellers are using the user data, so of course they should pay for the data, and the user can get some incentive, for example, some discount on their purchase. So this is like an incentivize. In the end, I think it's a kind of incentivize back to the user. So of course, some user can think, I don't want to share my info with anyone. But what if you just share a little bit of aggregated or anonymized data with some business, and they can give you something back? Then I think that will create a very good feedback loop in the ecosystem. Yeah, just imagine.
On the flip side, what would you say are some potential risks when it comes to these incentivization schemes? Because we don't want to attract, for example, bad actors or people who are trying to play the game. What risks do you see with these incentives?
Yeah, I think if just follow my wild idea, then the biggest challenge is how we deal with those privacy data. Because if I think dealing with the privacy is much harder than dealing with the correctness on the blockchain. Since blockchain is just, everyone can verify the blockchain. So if there's anything wrong, you can immediately figure it out. But if it's just some privacy data, it may go to the first provider, the second provider, the third provider, and one of them can have a copy of the data, and you even cannot notice that. So the leakage of the privacy, to me, is the biggest challenge here. But since there are a lot of new technology evolving, probably we can have some solution on that. So for example, multi-party computation, everyone can use the data, but not leaking the data in the whole process. Or something like running on our network, we have some decentralized backend. It's like a black box. So running the program to process the data doesn't necessarily mean they have the access to the raw data. Yeah, but I wouldn't say any of those solutions can be a final solution to the problem. But yeah, I'm pretty optimistic about the evolution of technology.
I think I have to undo. It's my bad. Probably I shifted the debate to the private data, but now thinking about the oracles, which mostly are talking about real world data, and they're moving in a different space. I think there is not much space for bad players because the full technology is designed for that. But the thing is, what I see, and I'm not an expert in that world, but what I see is a lot of fragmentation. When every system creates a new token, right, to incentivize the players, you are keep fragmenting the liquidity. You keep creating a new reward ecosystem that has its own dynamics, right? We have plenty of tokens. We have already existing blockchains. So, in my opinion, it would be better to use the existing dynamics of the blockchain. Like, hey, if all the data in the end is going to be consumed through a smart contract, right? Let's create the value in the smart contracts that already exist. Let's use the tokens that are already used, and then we can split the gains across all the players in the existing tokens and the existing blockchains, right? The fact that every new ecosystem is trying to create their own token, I don't know if it's really in the interest of the community that are going to receive the value, or it's more in the interest of who's creating the token, because basically it's a money printing machine.
We're almost at the end of the time, but before we wrap up, I would like to see from each of you in one sentence, what do you think oracles should prioritize next to advance the ecosystem?
I would say more data sets, like making more diverse data sets available on chain, and make aware their consumers that price data is not only what they have to watch.
I think from my side would be the addition of qualitative data, like we discussed before about reputation. I think quantitative data is under a lot of stress due to the manipulation that we are seeing in the markets.
Yeah, I think it's the barrier to create the oracle. So if we can lower down the barrier to create oracle, maybe any developer can create an oracle in 1-2 days, then we can get very rich data sets, and we can have the good competition between the oracles to finally, I believe, raise the quality of the data set as well.
Thank you. Let's see if we have any questions from the audience.
Thank you, first of all, to our panelists and moderators, everyone. And yeah, does anyone have any questions at all?
There's a question out there.
Thanks. It was a very enlightening conversation, different points of views. I'm coming from agriculture, and I'm primarily interested in blockchain for its blockchain for good use case. Agriculture is one of the biggest polluters of GHG, and my business is in Ghana, where farmers don't have access to internet. We are creating a system where they can contribute, as one of the panelists said, and get incentivized for data participation. I would like to know from you, and I think data privacy is not really a big thing for them because they are basically living on, subsistence living. So how can we create an oracle that basically overrides this conflict of interest where data fetching is taken care of? We are procuring absolute proof of origin, sustainable proof of origin, where the food is coming from, and the farmers, who are the most important stakeholder in the food chain, get the value for providing that data and the food along with it. Anyone can take that.
Yesterday during the hackathon, I think it was 2 a.m., a guy came with a project related to that, also for Africa, and he was trying to decide where the trust should come from, because in that case, his case was to prove the ownership of the land, right? And he was between using satellite data, right, with pictures from the field, et cetera, right? That was one possible option. The other option was to rely on human attestation, right? And the discussion was really, look, in these countries, the infrastructure is really low, right? So everything that is, and also you cannot foresee the amount of challenges that you're going to see just to get the most basic thing done, things that we take for granted here, right? The variability of the scenarios is huge. So trying to go, in my opinion, full automation in countries like that is a no-no. right? So in the end, after some time discussing, we say, okay, it's more feasible that the government certifies a number of NGOs that can perform the task of doing the attestation manually, right? And then they can do that attestation on the field, or they can find a process, right? And then the challenge becomes to secure the chain of trust because of the actors between the governments certifying the NGOs doing the attestation, that attestation being transferred across the chain until the final destination without any tampering, without any falsification, right? That is a classic supply chain problem, right? So that was the conclusion after that talk.
Yeah, I was leaning on the same direction, but I guess the more we lean towards the government, the more centralized it becomes. But yeah, it's a chicken and egg problem.
In the end, who decides the source of truth is the final verifier. So if the final verifier, if that's a supermarket or a distributor or whatever, right? If they decide that the NGOs are good enough, then you don't need the government, right? So is the verifier is the one really deciding how high you need to go.
Thank you.
Do we have time for one more question?
Okay.
All right.
Yeah, I guess. Sorry, that's all. And thank you so much to Bianca, Anastasia, Sebastian, and Hang. Yeah. So next up, we have. And next up, we have Thomas Ruiz from WITNET, who will be speaking about how to overcome the challenges of developing a truly multi-chain Oracle network. Thomas, everyone.
Sorry, Parvina, the remote control for the remote control, yeah. Or is this one? Okay. Okay, good afternoon, everyone. I hope everyone is enjoying this wonderful conference. And my name is Tomás Ruiz, and I'm the tech lead in WITNET. Today, I'm going to tell you, and you will see the different challenges that we have building a decentralized Oracle network, and also what we have gone through trying to deploy the WITNET contracts and the WITNET chain into the different chains that we are live right now. And then also we will see an example of how we try to solve those problems to make things easier for us. To give some brief context, WITNET is a multi-chain decentralized Oracle. We are a layer 1 that we have to build from scratch. And it's with WITNET, you can query any public API. So the data request creator can define with a domain-specific language that we have created, can define the different sources, can choose these sources, define how do you want to aggregate them, and finally how to kick out the outliers. And it's a highly parametric data request. Right now, we are live in 26 different networks. I have just seen a PR, and I think we are live in 27 right now. But yeah, we have gone through a lot of different challenges or problems trying to integrate. I have a huge disclaimer here. I'm going to say the names of different chains, different networks. That doesn't mean that these networks are better or worse in any aspect. We made a first integration with Ethereum, so what was easier for them was to go in EVM networks, and the ones that are more EVM compatible, they were easier for us, but it doesn't mean that they are better or worse. So the first thing that we face, or the first problem that we see when we were trying to integrate the first network that was not Ethereum, was that a lot of different networks were pushing us to deploy on their chain, and they were saying, hey, integrate this network. A network is super easy. It's straightforward if you already have an integration with Ethereum because we are EVM compatible. And the first thing that we realized is that Ethereum is not the same as the Ethereum network is not the same that that EVM compatible. So basically, when some protocol or when some chain tells you that a network is EVM compatible, it only means and only guarantees the compatibility between the Ethereum virtual machine. So your smart contracts are going to work, but maybe the ecosystem is going to be completely different, and MetaMask is not going to work, or your Web3 library is not going to work either. So the second problem that we face, or the second thing that we see, was that for some networks, they have different native tokens. For instance, in the case of Cello, which is a layer 1, they have 3 different native tokens, which are stable coins, which are pegged to the euro, the USD, and also the Brazilian real. So we had our transaction with some shape in the way that you are interacting with Ethereum. All the things were equal, and we had to adapt some things to being able to send or to use Cello, because the transaction format in Cello, it depends or changes according to the token that you are using to pay the gas. So we have to build something that we will see later to being able to consume those, to be used or to use that chain. And also this was a bit easier in the case of BOBA. BOBA is a roll-up layer 2, and they have 2 different native tokens. The first one is the BOBA token, and also the token of the network, the base layer. And first you need to send a transaction defining or signaling which is the token that you want to use for paying the gas. Then there was something also related to the gas, in this case, the gas limit on some layer 2s. We experienced that in the networks that are a fork of Optimism, for instance, BOBA or Optimism itself, when you are on a layer 1, the gas limit is a constant thing according to the type of transaction that you are sending. So every time that you are going to call to get the gas limit, you are going to call a provider, you are going to get the same result. But when you are in some of these layer 2s, you are going to experience that some gas limit will vary according of the cost of running that layer 2. And you could even have something that is not measured in gas units, it's measured in something different because they decide to grab this. This was, or as far as I know, this is how it's right now on BOBA. In Optimism, they made some changes, and every network has adapted this to fit their needs. Also, a huge different kind of networks. If you are familiar with Substrate, Substrate is a software development kit that allows you to create specialized chains, and you can use them to create EVM-compatible networks. The most common use case for this network is the Polkadot under Substrate ecosystem, and they were created using Substrate. So you can also create an EVM-compatible with one of their modules. Their modules are called palettes, and you can consume those palettes to compose an EVM-compatible network. But the main problem with that is that some chains that are going to use Substrate, they are going to say that they are EVM compatible, but all the ecosystem that they have is not compatible at all with all the tooling that we are used to use in Ethereum or the most common EVM compatible chains. So we were lurking in their documentation, and we saw that the Rift chain was based on Substrate. And we couldn't use MetaMask. We couldn't use the Web3 library. We could not use a normal wallet. We had to use their replacements. It was not difficult, but also the JSON RPCs were not compatible at all, and it was a lot of work that we have to devote to integrate Rift chain. So another thing that we found is that the JSON RPCs are the way that we have to interact right now with a chain. And the main problem that we saw is the lack of uniformity in the JSON RPC providers. We even found some interesting JSON RPC providers that they decide to give their service or expose their service as a GraphQL endpoint, which is not common at all. And we had to adapt all the methods that we had or we were calling to interact with a JSON RPC to being able to call a GraphQL endpoint. Also, something funny that we have found in a lot of different JSON RPC providers is that they suddenly stop working. We trust or we use quite reliable JSON RPC providers for Ethereum, for the bigger chains, but some networks or some chains that are starting to work, they could have that problem of faulty JSON RPC providers, or suddenly for any reason you get banned, or you achieve some rate limit, or something that we have found in a lot of different chains is that some methods that they should be available, or apparently they exist in Ethereum, or we have been using in some integrations, suddenly in one chain for any reason that they had, they are not supporting that method in the case of the Ethereum sync status. So also, when we are integrating a new chain, we have to take into account that every network has their own specific nuances. So every network is going to have their specific gas limit. They are going to have a different finality. You will need to take that into account for any business logic that you would like to implement, or you will have to expect to have a different tooling. The ecosystem tooling could be completely different. And the layer 2s also could rewrite or overgrab the methods, and you are calling one method in one layer 1, then you call that layer 2, and you are going to have a different behavior just because they decided to change it. So to make things easier for us and to being able to call all the different methods as the way that we were doing it in Ethereum, we created a JSON RPC gateway. The name is a bit wordy, but we are open for new names. Basically, this JSON RPC gateway, what it does is to grab the JSON RPC calls. It grabs the provider in a clear and manageable way. So you can handle accounts and you can delegate the calls to the third-party providers. And the most important thing for us was if we have a DApp, or if we have a service where we are deploying contracts from there, we don't want to have that service exposed to the public. We prefer to have that in a private service, in an internal network, and we access that to a public endpoint, but we don't have any key or anything sensible. We don't have that exposed. So, but for this case, the main benefit of using this JSON RPC gateway is that allow us to call all the different chains that we are integrating in the same way that we will be calling any EVM network. So if we were using or if we were calling one of the methods that I told that they were not available on a network, we will be able to call them. Could handle that error, but we will be able to achieve that. So it works in a really easy way. We have an app, a user, someone who wants to interact with a JSON RPC. And there's a middleware that in this case is going to be our JSON RPC gateway. And you will have to specify the provider that you want to use under the hood. You could use Infura, Alchemy, any provider, or you could even call a node that you are running. And you will call it in the same way that you are going to call Ethereum, and then this middleware is going to format the transaction to handle the parameters to be exactly the same that Ethereum will be expecting. They will transform them into the way that the specific network needs, and also it will grab and normalize the result to give you what you were expecting. So this was an easy thing to do for some networks. For instance, when we made an implementation for Conflux, we were able to find almost one method for every Ethereum method. And basically, we just need to create a dictionary. And that dictionary, when we are calling the Conflux network, we are just grabbing and using that dictionary. So we have a one-to-one relation. But there were other networks, like the case of Riff, where those methods, they didn't have the same name. Even they didn't have a similar name. The parameters were completely different. The units that they were expecting, their inputs were completely different. They have even a different address format, and we had to make different conversions, and we have to overgrab all the different methods to make it compatible with a JSON RPC gateway that is common in Ethereum. So the way to use it is quite simple. You can just download it or use it as an NPM package in your project, and or you can just clone the repository on GitHub. You just need to specify some environment variables. For instance, you have to specify the port if you want to run it as a server, the network in the case of. For instance, if you want to use Rinkeby or Robsten or any network, the seed phrase if you want the gateway to handle the accounting for you, and the provider that you are going to use. And as every network has its own nuances, every network needs some specific parameters. For instance, we have a lot of different configurations and a lot of different environment variables that we have defined, and you can pass. And the gateway is expecting to handle some methods, to remove some methods, to ignore others. And as this could be a quite challenging, or we have gone through a lot of different networks, we know which environment variables we have to pass. So we have created an NPM script for each one of the different networks that we have. So if you want to use this and take profit of our work, you can just consume it as they are, or if you have any specific business logic that will modify how you are consuming it, or you don't want to have a specific assumption that like we are having for some providers, you can just override them. So the main takeaways that we can extract from all the work that we have devoted to implement or deploy contracts in a lot of different networks is that EVM compatible means, it doesn't mean what most people think about, which is, okay, EVM compatible means that all the ecosystem is compatible, that all the different things of that ecosystem are going to work. So there are a lot of different Ethereum flavors or Ethereum compatibility flavors. So you will have, if you are integrating a network that is EVM compatible, you could struggle, or it could be, if they are just a fork of Ethereum, it will be much easier. So the only thing that you can guarantee when you are integrating an EVM-compatible network is that the contracts are going to work and the EVM opcodes are going to work. And basically, we built the Web3 JSON RPC gateway for two reasons. The first one was to achieve uniformity between the different networks that we were deploying, and also we wanted to isolate and have in a private network, our service that was handling our accounts. And I think I'm right on time, and there are some times for questions. And thank you, everyone. If I don't use too much Twitter, but if you want, you can follow me or send me a direct message. Thank you.
Thank you, Thomas. Do we have any questions for Thomas?
No?
No? OK.
They are free.
Or you can, catch him after his talk if you'd
Thank
like to deep dive with him. But thank you. And next up, we have Simon Schmidt from Edge and Node, who will be discussing new use cases and benefits from using subgraphs.
Thank you. Hello. Do you hear me? Is it good enough? Nice. Woohoo! That works. Yeah, busy week. Thank you so much for taking the time to still come here and ingest some information. I hope it's useful. My name is Simon. I'm Developer Relations Manager at Edge Node. That's one of the core dev teams that is working on the graph. And in this talk, which is a new talk, I quickly go through this idea that was once coined, I think, 1 year ago by Brandon Ramirez at the Graph Day. And it's going about the subgraphs into read-oriented rollups. It sounds a little bit weird, but we will build it up over time. So just a quick recap. What is the graph today? So it's a PDF. That is a GIF otherwise. So like the graph is basically taking that mess of marbles and organizes it. And that's what the graph does on data, of blockchain data. So it's very well known for this middle layer in between a front end and the contracts as the data layer that provides the data for these front ends in a quick fashion. So it indexes the data on the blockchain, prepares it so that the front ends can quickly use it. Well-known dApps like Uniswap, Analytics, for example, uses it, and much more. So it's actually a little bit an industry standard for that specific use case, like a front end that has data needs and needs of data through the graph. So as I said, like we also talk about the graph being the data layer of Web3. So the vision is really to become like across all chains and all protocols to have this data layer. And the graph is not just like a service provider. The graph is a decentralized network where we have currently 281 individual indexes across the world, bunch of delegators, bunch of curators, and 1,000 subgraphs deployed to more than 1,000 subgraphs deployed to this decentralized network, so that we can really create access to that data. And up to today, we have almost 3 million GRTs and query fees claimed on that decentralized network, so that query market is working, and that leads to truly decentralized data. Like the data that is on the graph is open and accessible for everybody. So that's the graph. Quick recap. So then let's go to this read-oriented rollup. So what is this, and what are subgraphs anyways? So a little bit more technical. A subgraph is basically a curation function, so that we can say which information on the blockchain is interesting and how do we want to store it, and then store it in an index so that we can later on consume. So the data comes from the blockchain. It usually just starts with the blockchain, gets into mappings, which are written in assembly script or Rust now with the substreams, the new technology, and then stored in a database, and the mappings can also access that store, and in the end, a consumer can query it. So it's very simple data flow. In my presentations, here, when I click, there is like it's a magic stick coming, because I think the magic lies in the assembly script and in the Rust. Why? Because the language that we write the subgraphs in, it's assembly script or Rust with substreams, and that is Turing complete. Turing completeness means that we can code everything, like that we can code with Solidity or JavaScript or TypeScript or whatever, like Turing complete general purpose language. We can code into the subgraphs mappings. So, for example, we can have a Merkle tree prover that checks in the subgraph if an entity belongs to this Merkle tree. Or we can have like some CK proving algorithms that would be too hard to run on-chain, can run in a subgraph. Or even like I saw a side project from someone that created a synthesizer inside of the subgraph that, depending on the block an NFT was minted, created a different kind of music, all happening inside of the subgraph. So the interesting thing is here we can use that technology to run quite complex or like expensive computing that would be too expensive on a normal network or especially on-chain in a subgraph. So that's very cool. That already gives very cool use cases. And then 2 years ago, this guy, Denison, he runs Tally, he played around with this idea of like, oh, wait, so when we can have like all this logic inside of a subgraph, what can we then build with that subgraph? And he came to this kind of meta idea of like, hey, we can have a blockchain into the subgraph that connects with stuff on the main chain, or like even he talks here about Ethereum. I think gas prices were lower back then, but we can also think of Gnosis or Polygon or whatever that then just trigger stuff in a subgraph. And the code actually in Solidity to facilitate this is like this. It's basically, we have a contract, it's called the data edge. There is a specification about the data edge. You can read it in the GIP. I will later on also link the slides. And then that just has one function, the fallback function, that's always called when we call that contract with a function that doesn't exist. And that's it. And it does nothing. But what happens when we call that function is like that everything like all the call data that we send to that function gets stored on chain and can be indexed by the graph. And that's how they started to build that social network on top of it, because they just send a JSON that says like create post from blah content X, and the subgraph was able then to build a completely database that was displaying that data. So that was fun in a way, and it's interesting to think about. But it's also like, I don't know. Yeah, let's see how important that can become. So what's basically happened is that the logic moved from the blockchain to the subgraph, to the mappings. But actually, so this is the first primitive. So we have like Turing completeness in the mappings, in the subgraph, we can run big code. So the next step is the off-chain data. Now it gets interesting. So the graph has the possibility, or the graph network, to also index data from IPFS and RVIF and then add it to the mappings and put it into the store. So now we can mix and match. So in the social network from before, we can upload that pose just to IPFS and then anchor it down to the data edge. It gets then indexed, stored, and we can query it with everything that we have. But that's not all. Like the team at EdgeNode started to create this. So like the graph network, there are multiple gateways across the world, and then multiple indexes across the world, and queries go to the gateways and then to the indexes. What's very important for every kind of stakeholder of the graph network is we want to know like what's the quality of service, how do these indexes perform. That's kind of something that gateways know in a centralized way because they have like Web 2 connections. And now they worked on this idea of republishing that data. So how does it work? Every gateway that is there has logs. They know like, okay, I sent this request to that indexer, it took that long, and that's it. And then they put it to this data science pipeline, and Red Panda materialize. That's not my thing, but in the end, there is a cron job that uploads that big data. It's a lot of data that is there into IPFS, anchor it back with OpenZeppelin. These things that we can trigger on OpenZeppelin to write on-chain, and then the graph indexes it, goes back to IPFS and has it. So now we have a network quality of service or Oracle subgraph that we can query and see like which indexer has which quality of service, which subgraph performs how, and so on and so forth, all in a very decentralized way. We can even think about other use cases that come here, like, I know, it could be any Web 2 data, basically. It could be hotel rooms that are free. It could be airline seats that are free. They all can be the same, uploaded to IPFS, anchored on-chain, indexed by subgraph, make it available through the subgraph. Or also, like, a very interesting use case would be we can have weather stations that do the same. Like, we have hundreds of these weather stations. They all upload that data, anchor it on-chain. The subgraph gets it, combines it, aggregates it. And then we have, like, a current weather or, like, a very good information about how the weather is currently look like. And that all builds on top of what's already there with the graph. Like indexes are already there, so we don't need to even think about infrastructure, because if the subgraph is deployed and IPFS deployed, the indexes index it and make it available to query. And the other stuff, also payments, indexes get paid to serve queries. Curators can curate on subgraphs in order to participate in the query fees. So the whole power of a decentralized network with all the incentivized different stakeholders can be used to also publish Web 2 data. And now even this week, we launched this new billing thing on the graph network. Before, like we had to bridge GRT to Arbitrum in order to pay for the query fees. Now there is a super simple subscription thing where we can just say like, okay, so that many queries, boom, per month, that's it, deposit USDC, and then it just runs. So if anybody's interested in running that, find me, we can help you. But now we got even one step ahead. So now we have all this data. We saw like it's blockchain data. We can even calculate on blockchain data maybe more complex risk parameters or something like that. We have the off-chain data that's on IPFS, but now we can bring it even back on-chain. So how would that work? So we have the blockchain mappings again as before, and now instead of just a consumer that might be front-end or a data science application, we have an oracle that brings it back. Chainlink launched the Chainlink functions, I think a month ago or two, and at this hackathon and also like during the FCC, saw different examples. There's actually a live code example how to use the graph in Chainlink functions to bring data that's on the graph pre-computed or prepared for whatever use case we have back on chain. Also, Gelato has Web3 functions that can do the same. So now we have the whole flow of data. So to finalize and talk about this read-oriented rollups and why this model that I just explained kind of fits into this narrative is like when we have a rollup, like in this example, a CK rollup, we have a state that's created on the CK rollup, then it's proven and put down to L1, and transactions can also go up. Like there's this interaction between. And now when we have read-oriented rollups, it's a little bit similar, but like the state comes up, it will be pre-computed or computed and changed on the L2 or then in the subgraph, and then can be rolled down again with the oracles to L1. So that's where this read-oriented rollups idea comes from, and that's kind of explained in these things. So at the end, I just quickly want to go into this one big topic, which is probably the elephant in the room when we talk about oracles data in general. It's like verifiability. Like, how can we trust the data that we see? It's one topic that is very core to the vision of the graph, that really this idea of like, okay, if you see Web2 data, do we know if we can trust it? If we see data from a centralized data provider, how do we know if the data provider does actually giving us the right data or not? So if we, I don't know, go to a centralized data provider and ask for a price of a certain token, the centralized data provider might give a wrong quote in order to game the system a bit. So with the graph, with the current implementation, it works like this. Each indexers need to stake. Some indexers stake more, indexers stake less. Whenever, then there is two steps. So first, they do indexing. They see data, they index it. They compare, like indexers compare with each other, like which data that they see. It's so-called proof of indexing. So they hash, basically they hash the data in set intervals, we call them epochs, and put it on chain so that the others, so that we can compare. And that's one. So we see, okay, the indexes saw the same data. And then the second, obviously, is like then the querying. So the proof of indexing helps with, I would say, faulty software, because they can compare, did we see the same data? But if a malicious indexer, for example, wants to return wrong data, like consciously, then it would happen at the query layer. So what indexers do is, like with each response, they send a so-called query attestation. And with that attestation, we have a response to that query and that attestation, and later on, when we can prove the indexer wrong, that response to that query was actually wrong, the indexer can get slashed. And that's how these oracles also work. So they take the response, put it on chain, but also the attestation. And also with Chainlink, we take then the responses from different indexers and combine it and see if there's any difference. And if it's all good, we put them on chain with the attestation. And if we later on see that something went wrong, we can slash the index. So that's not perfect. It's kind of optimistic. So that's where actually we can go to the future. And there is the one core dev team is particularly at the graph, Semiotic from Los Altos. They work on this big problem of called verifying indexing and querying, kind of having the whole stack, like the indexing, really verified with this CK proofs of what they saw. That's also a little bit below above my brain level, but like that's kind of the end goal, to really have like, I receive a response from a graph indexer, and I can check the response with the attestation directly without needing to trust. So that's where we're headed, and yeah, hopefully we will achieve that state soon. But until then, thank you so much for coming here and watching that talk.
Thank you, Simon.
You can also scan the QR code, which will lead to the link to the slides, where there is a little bit more context, links and stuff. Yeah.
Thank you. And do we have any questions? Okay, no questions. Thank you so much.
Thank you.
And next up, we have Patrick McClurg, who will be speaking about how to achieve truly random outcomes using DRAND. Patrick, everyone.
Good afternoon, Oracle nerds. I'm Patrick. I'm from the DRAND team inside Protocol Labs. You may have heard of Protocol Labs from IPFS or Filecoin or libp2p fame, but there are yet more good projects that we've developed, such as DRAND, which I'll be shilling toward the end of the presentation today. So first off, what is randomness? Well, there's lots of fancy academic definitions of that, but for this presentation, we'll just assume it's choosing a number from a range which nobody can guess at a rate better than chance. Okay, so what can you use it for? You're probably all pretty familiar with randomness here, but here's some example use cases. For instance, your Bitcoin private key is essentially a big random number. Anytime, if any of you people have done the lottery, the dude with the white glove who selects the balls from the weird machine that spins around and around, that's essentially selecting random numbers. In the top left, we've got Magic the Gathering, a legal drug that strips nerds from money all over the world. Shuffling a deck is, in essence, coming up with a random permutation. Selecting people for jury duty is another example of using randomness. And some of the keen-brained among you may have noticed some of these applications are not quite like the others. In essence, some of them use public randomness and some use private randomness. So for example, Bitcoin, you probably don't want to tell anybody your Bitcoin private key because they're going to steal all your Bitcoin. But obviously, if you used private randomness to select jury duty, then it could be biasable and people might pick the same people every time. So that kind of leads nicely into one of the problems, difficulties with doing randomness on chain is on the blockchain, everything's public. It's also deterministic. So in the deterministic sense, computers are by nature deterministic. So it's quite hard for them to come up with random numbers in that it's not very random if everybody can just do the computation themselves. So we need to find some method of achieving randomness on the blockchain that can't be influenced by others and also can't be predicted by others, or you're not going to have very good lotteries, for example. So looking back to some of the early days of blockchain, when it was just coming out and we didn't have lots of fancy oracles and other tech, a lot of people used block headers as a random value. And for low-value use cases, maybe some tenet of a game, for example, that might be good enough. But the issue with block headers is, of course, that they're biasable. You can imagine if we had a lottery that was worth millions and millions of dollars, miners may choose to include or not include certain transactions in a block to try and influence the value of the block header so that they could potentially win the lottery or make sure certain people don't win the lottery. So, we've come past that stage, but that was something some people used in the past and probably not good if you're doing anything important. So the next stage along in Ethereum land, at least, was to create RANDAO, which you may have heard of. It's kind of the go-to source of randomness native to the Ethereum blockchain. And as a quick refresher for anybody who doesn't know how RANDAO works. Essentially, we've got 128 slots rather, in a smart contract. And people with a stake can provide some entropy into this contract. And in fact, it happens in two phases. First, they commit to some piece of entropy by providing a hash of that. And then at some later phase, they reveal or choose not to reveal their entropy. And all those bits of entropy are combined together into some final random number. So that sounds pretty good. It sounds like, you've got 128 people. It sounds pretty random. But the issue is, it's biasable. In essence, if you're someone with a lot of stake in the Ethereum network and you manage to get a whole bunch of these slots, particularly at the end, you could choose to reveal or not reveal your committed randomness in order to influence the final result. And each slot adds up to around a 1-bit bias on the output number. So again, depending on the value of your use case, this might still be enough. Like, if someone like Coinbase who owns lots of slots in RANDAO want to, try and, win your fancy sword NFT in your game, that's probably not worth their time. But equally, if you've got a lottery worth bazillions of Ethereum, then maybe it is worth their time and they might pwn you. But we moved on from RANDAO, and of course, this is an Oracle conference after all, so we've got fancy oracles for this. So you could use a VRF. For legal reasons, I've just included a picture of a chain link fence here. I'm not referring to any specific VRF here, but okay, so VRF's a little bit better here. No, it's not biasable in the same way that RANDAO is biasable. They've published lots of fancy algorithms about how it works. And you can dive into the details, get a cryptographer to look at it, and all looks pretty good. However, it's got a couple of issues. The first is, well, it has single-party trust assumptions. I mean, if you're using unnamed VRF Oracle for certain blockchains, you're kind of relying first that they've developed it correctly, secondly that the details they've released on it are correct, thirdly your PhD Galaxy brain that you've hired to look into the details has correctly read it and it actually works as you expect it, which that's a lot of assumptions, which again might be good for your use case, but could also be scary. Additionally, it can be quite expensive. So if you have to do lots and lots of logic in your callback for certain VRFs, you get charged a percentage of the gas fee. So if you're doing loads of computations, it's going to be very expensive for every random call. And yeah, maybe if you're handling billions of dollars, maybe that's a small fee, a small price you're willing to pay. But we can do better. Another possible route for randomness is using threshold cryptography. For those of you not familiar with threshold cryptography, it's in essence taking a public and private key pair, but splitting the private key into a whole bunch of mini private keys or partial private keys and distributing them amongst a bunch of different people. Those people then have to come together and work cooperatively to act on behalf of the private key. So, for example, if we have n participants, we need to cross some threshold number of those working together in order to output a signature that is valid for that public key. The cool thing about threshold crypto is that no single party ever has the private key in memory. So if we wanted to create randomness, we can sign a message, and because nobody has access to the private key, they can't anticipate what the signature is going to be over some message, and therefore it's indistinguishable from randomness. So, ooh, now we're talking. As a side note, threshold cryptography, very cool for some of the other things we've talked about today, like data provenance, for example. We could give some data to a whole bunch of people and get them to sign it, and we can, that gives us a bit more spread trust on that someone has actually seen the data and verified its validity. And now for the shield part of my presentation, ooh, a wild DRAND appears. So what is DRAND? Well, it's a threshold network for generating publicly verifiable, unbiasable, unpredictable random numbers. I've gone into the threshold aspect of that a little bit already. We've discussed publicly verifiable is super useful on chain, and because the random number is in essence a signature, we can use all the usual suspects for verifying signatures that we're all used to, rather than having to rely on some hard to figure out VRF. A sort of confusing part of the threshold signature idea is that, in fact, all the random numbers from here until the end of time are already deterministically decided once you generate the key. So in that regard, it's unbiasable. Even malicious nodes can't create a valid signature that will turn into some valid randomness. But because, again, nobody has the private key, it's unpredictable. So DRAND signs a message every epoch using some fancy maths. Those DRAND epochs map to a precise time on the clock, which means that we know the message in advance that the network is going to sign, which enables some other cool things that I'll talk about in just a moment. And right now, DRAND emits randomness every 30 seconds. We've actually just launched a new network that emits randomness every 3 seconds, so that could be good for some specific gaming use cases. And coming back to quashing the single-party trust assumptions of some other randomness models, DRAND is run by a non-profit consortium called the League of Entropy, which consists of 16 organizations, some of which you may have heard of, such as Cloudflare. Also, a lot of universities like EPFL, UCL, University of Chile. There's some Web 2 companies, there's some Web 3 companies, Protocol Labs, they're great, Ethereum Foundation. And the crux is that as long as there are never a threshold number of malicious nodes in the network, you can trust that everything is above board and legitimate. And compromising a threshold number of very different, geographically distributed parties would be quite challenging. I said a moment ago that it enables something else that's very cool called time lock encryption. Essentially, the ability to encrypt something now that can't be decrypted until some future time has passed. Although that's outside the scope of this talk, but if you want to try it, I've got a QR code for you to scan, which I'll give you 10 seconds here to get your phone out and do the business. There's a paper and libraries and all manner of other cool things that you can read up on time lock encryption there. So finally, I guess some asks for you. Let's collaborate. I think threshold cryptography has a lot of cool applications in the Oracle space. In particular, DRAM right now isn't on a lot of chains, so it's available in the Cosmos ecosystem thanks to the Noise Network, who are also an Oracle provider, specifically for randomness. It's available in the Filecoin virtual machine. It was available on Terra, but unfortunately, not anymore. It's kind of available on Ethereum, but unfortunately, BLS 12381, i.e. the threshold signature scheme we use, the operations for that are not native to Ethereum, and they're very, very expensive in gas cost. So if you can shield this EIP in the bottom right to get them accepted into Ethereum mainnet, not only will you enable DRAM verification on Ethereum, but also all the cool Oracle use cases using threshold cryptography will become available to all of us. Also, if you've got some infrastructure, you could join the League of Entropy as well. We're always looking for new members, as long as you can run a production-grade infrastructure and your servers won't fall over. Yeah, that is everything I've got. Here's some cool links as well, and I'm open to any questions from the floor that you might have on DRAM or threshold cryptography.
Thank you, Patrick. Yes, does anyone have any questions?
Very quiet bunch today.
It's been a long week. Oh.
Do you have any numbers about like who's using this on Ethereum?
So nobody's using it in Ethereum at the moment. This project, RNGesus, was developed in a HackFS recently.
Oh,
so it's only actually available in the early test now right now,
okay.
because they didn't want to spend all the money to put it on Ethereum. The issue is verifying beacons on Ethereum right now is quite expensive without the pre-compiles, even though the EIP's been up there for ages. Although it may be available via some bridging to, for instance, the Cosmos ecosystem, which is the blockchain of blockchain of blockchain of blockchains. But additionally, if any Oracle providers here are interested in bridging DRAM randomness or providing an Oracle for DRAM randomness onto some of these chains, we'd love to talk to you. We know DIA Data, who are an Oracle-y infrastructure provider, are providing it somewhere, but not on Ethereum right now. So yeah, if you'd like to.
So who are your primary users?
So the primary user is Filecoin Network. So it uses DRAM randomness for leader election, for challenging storage providers on proofs. We also have a couple of gaming companies using it. So Pirate Nation, who I think might be the biggest game on Ethereum, are using it. Although they don't verify the randomness on chain, they just kind of do that out of band and put it on there. Additionally, we've got a not-for-profit who are doing a universal basic income in Sierra Leone, are using DRAM to select who receives the universal basic income so that some warlords don't come along and steal all the cash. And there are a bunch of others, but those are the cool ones.
Thanks.
No disrespect to our other users who are also cool.
Thank you. And any other questions? All right. If that's it, then thank you so much, Patrick.
Thank you.
And as mentioned, Alberto Melon was unable to make it, so we'll break for coffee and meet back here at 4:30. We will have the last 4 talks by Lagrange, Succinct, Chronicle Protocol, and Gearbox Protocol, so don't miss out. Okay, welcome back, everyone. I hope you enjoyed the break. Now, we have in the program Ismail from Lagrange, but he's speaking next. First up, we have Uma from Succinct Labs, who will be speaking about Succinct's cross-chain messaging and state queries.
Hello, my name is Uma, and yeah, I'm talking about Succinct's telepathy protocol, messaging, and state queries. So just some background on Succinct. We're basically interested in exploring the rich ZK protocol design space beyond just the current two flavors of prominent ZK protocols, which are ZK EVMs and privacy-preserving protocols like Tornado Cash. We think ZK is this really powerful tool that has kind of promised to scale blockchains and supercharge them in a bunch of rich, interesting ways. And we're exploring this question mark, which is, are there other stuff with ZK you can do beyond ZK EVMs or things like Tornado Cash? So we thought a lot about this problem, and we realized that one area that ZK is currently underutilized for is for interoperability. So over the past year, we've been working on this concept of ZK-like clients, which is basically verifying consensus in a ZK circuit. And at a high level, ZK lets you basically compress computation, which is why it's really useful for scaling blockchains and used in things like ZK EVMs. But we also realized you can take those same scaling properties and apply them to verifying consensus. And this is useful because say you have a source chain, like Ethereum, who has consensus. You can verify the consensus of Ethereum in a ZK snark circuit, and then you can verify it in the execution layer of another target chain, such as Gnosis chain, or really any other Alt-L1. And then you can have this target chain basically have access to Ethereum's state natively without the need for any multisigs or trusted operators in the middle. If you guys are familiar with the current state of bridging protocols today, many of them do the same sort of get Ethereum state on another chain, but it relies on a small group of trusted actors in a multisig to sign off and attest to the Ethereum state, and then have that available on the other chain. What we're doing is we're just letting this other chain directly verify Ethereum's consensus natively, and do that in a very efficient way by verifying a ZK proof. And so we have this succinct ZK-like client running on other chains that's really gas efficient to run and really cheap to verify. And with that, we can have chains talk natively to each other. So more concretely, there's this concept of the ZK-like client that I just introduced. But concretely, what we built is we built a ZK snark that lets you verify Ethereum's like client protocol. And in particular, our snark enables the verification of Ethereum's consensus for around 300K gas on EVM chains. And how it actually works is you have Ethereum consensus, which as it's going through its process, it's generating blocks, it's generating an aggregate BLS signature of all the validators, and it also has this current validator set who are the people who have staked. And then we take all of those outputs from Ethereum consensus, we put them into our ZK prover, which generates a ZK proof. And in particular, the statement it's proving is it proves that a block header has enough signatures from the current validator set. So the ZK prover spits out a proof, it spits out a block header, and it spits out the number of signatures. And we take all that stuff, we put it on a smart contract that's a light client on chain. And then our light client on chain can verify the proof and then keep track of the headers of Ethereum. So our first protocol, Telepathy, is currently live on mainnet. It's been live since March. And it uses our Ethereum ZK-like client. And with this, you can do a few things. So the first thing you can do is you can send messages from Ethereum to any chain that has our light client running on it. So in particular, what this kind of means is that we'll have our light client running on any other chain you can think of. It has access to Ethereum's block header because it's verifying Ethereum's light client protocol. And then with that Ethereum block header, you can verify whether or not a message was sent on Ethereum. So you can, using this primitive, you can send messages from Ethereum to other places. This is really useful for protocols like, for example, Compound, which recently gave us a grant to do cross-chain governance, because Compound's governance is conducted on Ethereum because of their comp token, which lives there, but they often have deployments across many other chains like Polygon or Avalanche, and they want to control the parameters of their deployment on those other chains, but the votes happen on Ethereum L1. So it's really useful to be able to send messages from Ethereum to other chains without the need for some trusted multisig in the middle, as that would kind of defeat like the whole point of governance. And then also what our protocol lets you do is it lets you also have access to Ethereum's consensus layer and the execution layer. So because we're running this Ethereum ZK-like client, we actually not only have access to Ethereum's block headers, we actually have access to Ethereum's beacon chain, which is its consensus layer's headers. And that beacon chain state commitment has a lot of very useful information, such as whether a validator was slashed or not, or validator balances. And that sort of information is really useful for protocols that need access to consensus layer data in the execution layer, such as liquid staking protocols or restaking protocols. And so we're working with the eigenlayer team as an example, who runs a restaking protocol, because they need to operate their protocol information about the validator balances and the validator state and withdrawal credentials. So all of this is done with the security of Ethereum's light client protocol, which is really nice for all our users because they don't have to trust us, they don't have to trust any multisig. They're kind of just verifying natively Ethereum's light client protocol and then getting access to this information. And then we're also being used live in production by Gnosis Chain, which is an all L1, to secure their bridge from Ethereum to Gnosis. We're being used by Across, which is a liquidity layer, which uses us to pass messages from Ethereum to other L1s like Avalanche. And yeah, there's a few other people who are using this arbitrary message passing from Ethereum and the consensus oracle in similar ways. So this is just a code example of how to use our protocol. I want to highlight, like, this is an entire cross-chain counter, so it's very, very simple. Basically, you can see that you have a source counter that has this send function, and you just specify, hey, what chain do I want to send it to? The destination chain ID. You specify what address you want, and you specify some bytes. And then on the other side, you just have to implement in your smart contract handle telepathy, and you basically verify where it's coming from, and then you receive the data. And this is really nice because it's really easy to integrate and pass these messages. It's very similar to a lot of other message passing protocols. And then this is an example of the consensus layer. So again, I mentioned that a few people use the consensus oracle we have to basically read validator balances or validator status or things like validator withdrawal credentials. And so this one is like a little more complicated because the validator information is more complicated. It's not just simple bytes. You have to prove different fields. But this is an example of someone using us to get the beacon validator balance for a particular validator using our light client. OK, and then now I want to introduce our new protocol, telepathy state queries. So it's not yet ZK-based, but we think it provides some like pretty interesting new functionality beyond just messaging. So for some context, cross-chain messaging is a very push-based system, interoperability system. So it really has this paradigm where I have a message on a source chain, and then as a user, I have to push it to the message and information to a destination chain. So in that way, the user or the dApp developers are responsible for pushing data from a given source to a destination. However, we realized a few of our early users actually didn't want to push information. They more wanted to pull this information from other chains just in time. So in particular, oftentimes, the workflow that they would prefer is that, say, they have some function of their dApp that's on some other chain, and then you want to be able to reference some data from Ethereum or any other chain throughout the course of that function call. And that data might be kind of arbitrary. It might depend on like the message.sender of who's calling that function. And that was the inspiration behind our state query protocol. So at the high level, state queries allow users to call view functions on other chains during the course of executing on a given chain. So some example use cases, that was pretty high level, but going through some examples of like why people actually want this. So one really common one that came up was that users want to conduct, or users, which are dApp developers, want to conduct, for example, voting on L2, where it's much cheaper than L1. So you might want your users to conduct some governance vote or some other vote on L2, where it's super cheap. But maybe you want to gate that voting by the user's balance on L1. So you might want to conduct some sort of governance vote, but weighted by some token-weighted voting where the token lives on L1. or perhaps the NFT lives on L1. So as a very concrete example, NounsDAO is this NFT that lives on L1. They have a very active community, but often voting costs like $20, and they are looking into how to do voting on L2, but of course the nouns live on L1, so they have to understand the user's noun balance on L1. Another use case some of our users wanted is Chainlink oracles generally post to L1, but Chainlink is not deployed everywhere on all the L2s that they might want to deploy their DeFi protocols on. And so a use case people wanted us to do was say, I have a DeFi protocol on L2, but I want to read the Chainlink oracle from L1. And that's kind of another good use for state queries. Similarly, say you have this perp protocol on L2, but it's on assets that are trading on an L1 AMM or on AMMs on a bunch of different chains. This is like another great use case of why you might want to read information from other chains. And the last use case I have here concretely is pretty similar to the first one, where maybe you're claiming some sort of reward on L2. Maybe your reward is small, so it doesn't make sense to pay L1 gas, but maybe the reward is gated by some L1 information or state. So our state query protocol, here's like a code snippet of how to actually use it. It's actually really simple. So basically, you construct this state query object where you have this chain ID, which is the chain you want to get information from. You pass in a block number, which is what block number do you want to use. You pass in the from address, which generally is just 0, because it's just the message.sender of the query, which is usually irrelevant for view functions. You pass in the address that you actually want to call, and then you just pass in the call data. So it's really just simulating an ETH call, any view function. And you can see here in particular, we're calling, I believe this is the nouns address, with the balance of selector with a message.sender of the transaction. And then you issue a request to our gateway. So we have a state query gateway. You pass in the state query object, and then you pass in some callback information. So you pass in what function you want in your contract to be called back with the result, and you also pass in any additional context that you want to be passed into the callback. So in this case, it's the user's option of what they're voting. And so this is just a more fleshed out example of L2 voting where it's gated by L1. So the kind of workflow, just to make it really concrete and show how simple it is, in this example, a user would want to vote for an option on L2, and basically the contract would issue a state query to L1 asking for whether the user has enough of the NFT. So it issues a state query, and then when that state query is fulfilled, it gets the result, and then it calls continue vote. And you can see if the user's balance is greater than or equal to 1, then the vote goes through, otherwise it doesn't. So it's really simple to use, and it's very nice because basically now you can just call view functions on arbitrary other chains throughout the context of your contract execution. And to talk a little bit about the protocol architecture. So our protocol architecture is fairly simple. Basically what we do is we have a contract on mainnet, which is a registry that keeps track of all the attesters. So the way it works is when you send a state query to our gateway, we have a network of attesters who listen for that query. They use the ETH call RPC on the relevant chain of the query, and then they get the result using the ETH call RPC method, and they sign the result. So we have this registry source on mainnet that keeps track of all the attesters. And then what we do is on all the other chains, we have a mirror of the mainnet registry that keeps track of all the attesters. And then our state query gateway on each chain uses this registry mirror to understand if enough attesters have signed off on the result. So this is a very simple protocol where if at least 2/3 of the attesters have signed off on the result, then your result is deemed as valid, and then it executes the callback to your dApp. So it is a very simple architecture currently, and right now we have a proof of authority updater where we just update the registry source on mainnet to keep track of who all the valid attesters are. And so right now the people running attesters are us and some of our other trusted friends. But one thing that's interesting is actually this architecture for the future can be generalized to not just be very simply attestation based. And in particular, we're very interested in using things like EigenLayer, where you can start providing economic security to back these attestations. So for those of you that are familiar with EigenLayer, EigenLayer is this company that's pioneered the concept of restaking, where existing Ethereum validators can restake their ETH and subject it to additional slashing conditions, and subscribe to other services and provide security for other services. So in particular, these restaked validators will be calling these ETH call queries and then attesting to the stake query requests. And then if they provide the wrong answer, they'll be slashed. And one thing that's really nice is even for optimistic rollups, because they settle after 7 days on the L1, you can get the ground truth of such a request after the optimistic rollups have been settled. And so you can actually get economic security with restaking for these queries for L1, but also all the optimistic rollups and all the ZK rollups. And so we're pretty interested in when EigenLayer comes out. Right now, they're more of a proof of concept. They have some initial deployments, but they don't have their full system working, basically augmenting our attestation network with economic security with restaking to have actual economic security backing our attestation and stake query protocol. And one interesting thing is for ZK rollups and L1s, we can use some of the concepts behind ZK EVMs to execute the bytecode of our view functions against state roots and provide a ZK proof of these state queries. So one really nice thing about our state queries is that they're really simple. You are able to put in any Solidity view function and get the result on any other chain. So it's very ergonomic for the developer, which is why we released it now, because we think it's a really nice ergonomic API. But then later, once enough people are using it, you could imagine a world in which we take the bytecode of a view function and we're able to run it through a ZK EVM that's read-only, because a view function does not create or do any of those other opcodes that actually alter the state. And what's really nice is then we can have a succinct proof of your view function execution. And so these are some of the future directions that we're interested in taking our state query protocol and augmenting its security in the future. Cool. That was, I believe, all I have. So thanks.
Thank you, Uma. Does anyone have any questions for Uma? Yes?
Attesters right now. How do those attestations work? Are they just ECDSA signatures, or what are they doing?
Yeah, the attestations right now are just ECDSA signatures. So, I think I actually forgot to mention this, but the protocol is live on testnet right now, and we plan to go to mainnet maybe in a month or so. The attestations are just ECDSA signatures, and then we just verify them on the chain, so it's pretty cheap. But you could imagine that, say, there's a ton of attesters in the future, they produce something like an aggregate BLS signature, or another signature type to accommodate, if there's a lot of them.
Sure. Okay. Cool.
Any other questions? No? Okay, thank you so much, Uma. And next up, we have Ismail from Lagrange Labs, who will be speaking about enabling trust minimized interoperability with non-interactive cross-chain state proofs.
I could have made that title a little shorter. In retrospect, I probably will next time. So good afternoon, everyone. My name is Ismail. I am the founder of Lagrange Labs. So we build infrastructure to increase the expressivity of how on-chain data can be used in applications. So we oftentimes think about the expressivity of a state machine in terms of the execution environment. And when we think about increasing the expressivity of execution, we typically think about supporting new VMs, new opcode or bytecode sets, and allowing developers to interact with on-chain state through more ergonomic and easy-to-use languages than Solidity. But what we don't often think about is how state itself constrains the types of applications that can be built using a state machine. So I'm going to start with a very non-controversial statement, hopefully, that state machines require state. And what is on-chain state broadly? We can think of on-chain state as the current value of all variables and all data in all contracts on a given chain, in addition to all transactions, all events, all receipts at a given point in time. And as every block is inextricably linked to the previous block, you can think of a block header as a commitment to a version database with discrete updates that have occurred from genesis through the current state. And when we think about cross-chain state access in the monolithic or the single-chain context, we typically think about accessing state in somewhat easy-to-use, predefined function calls. So how do you get state on a monolithic chain? Typically, you would be able to interact with all variables in your contract. You'd be able to access some storage in the storage root of the chain if you wanted to run an MPT proof manually. And you'd be able to access it through cross-application view functions. And when we think about this in the cross-chain context, things get a little bit more dynamic and a little bit more complicated. So generally, you'll have different execution environments. You'll have different storage trees, receipt trees, and transaction trees. And you'll have cross-application states that span a series of different execution environments, where access is fundamentally asynchronous. And so what this leaves us with, and this is how you can really think about state in the blockchain world today, is a data lake, a morass of asynchronously updated, different data structures that you are more or less unable to verifiably search, compute, or include the data from within your application. So at the point of execution, let's say of your contract on Solidity, you really don't have access to the same expressive types of computation that you would otherwise do in the Web 2 context, right? You can't query over on-chain state in SQL. You can't query multi-chain state and merge data in SQL. So you might say, well, what about storage proofs? I hear a lot of people at EthCC talking about storage proofs this year, and there are. But storage proofs are only a partial solution to this problem. Storage proofs allow you to say, at this point in time, in this memory slot, in this contract, there is this data. There is this value, these bytes. And while this is valuable, it is constrained in what it can show you. And with the computational overhead to access this data, you have to be very specific on what you're accessing. This is not a general purpose tool for querying over data. And so here's a thought experiment for everyone. Assume that you have a new contract, you have a contract on Ethereum. And this contract needs to access NFT level application data from a different, let's say the Pudgy Penguins NFT contract. And so you want to find all owners of an NFT, or sorry, all NFTs owned by someone with a pre-specified address. So how would you define this query off-chain? Very simply, you would just say, if it's on your database, select all from Pudgy Penguins contract where owner equals XYZ. You can think of an oracle, maybe if you were to index all this data off-chain yourself and then feed it back on and trust the oracle, you could do this too. But how would I do this on-chain? If my contract wants to trustlessly access this information from the Pudgy Penguins contract? Well, the answer is you'd have to run a loop on-chain through every single index of that mapping to figure out what every contract, what every NFT was in the index and the mapping, and then check who the owner was. Because it's a mapping on-chain, so it's a key value store, and the key is index and the value is owner. And so you can't query or index or search by the owner. And this is the case for most on-chain data. So you can't figure out how many users own USDC balances greater than X without going through every single index of all USDC balance owners. And so when you're thinking about on-chain state and on-chain data, there are certain questions you can ask. So who owns NFT X at contract Y? What is the price of ETH to USD on UniV3 at block N? But there are expressive and data-rich questions that you can't ask. You can't say, what are all the properties, what are all the NFTs owned by address X with property Y? what is the price of ETH to USDC on UniV3 over the past n blocks when factoring out outliers? Or you can't say, what is the standard deviation of price across this asset pair on this chain? And what is that over the last n blocks so I can derive volatility? You're fundamentally constrained by your access to data and the computation you can run on top of it. Now, this is where what we do comes in. What we allow you to do with our novel proof construction, called ZK MapReduce, is to compute over on-chain data in the single chain or the multi-chain context as if it was in your data lake. You can run MapReduce, Spark, RDD, and SQL on-chain state and prove the result to your contract with zero knowledge. Now, you might say, well, what is the security assumptions of the data? Because if the data is bad, the computation doesn't really prove anything. So this can be thought of as a transport layer agnostic proving system. So what this means is the block header that's used as the input to this proof can come from anywhere. If you're on Ethereum and you have access to block.header in your contract, you can just use that. So it's no security guarantees beyond the execution environment. If you are on an L2 and you can get the L1 state read from the canonical bridge, use that. If you're somewhere else and you want to opt into Layer 0 or Axelar or Polymer or one of the many cross-chain solutions, you can use their state root and their block header. And you can verify these proofs with respect to a predefined point of trust that you've established in an existing cross-chain protocol. It's not our job to tell you what state to trust. That's the job of the application developer. What we do is we allow you to establish that point of trust and now have more expressive and dynamic and data-rich computation sitting on top of it. And so what's required for a proof? Well, a block header, the thing we've been talking about for the last few minutes. Then a specific range of block numbers that can be proven with respect to that block header. And then a series of storage slots that are going to be used as part of this computation. Next, you specify the computation, and then there must be a contract in the destination chain to verify this computation that we deploy. So very simple, doesn't require much, and drastically improves the surface area of applications you can build. Now, what this does at a very high level is allow you to compute across on-chain state like a data lake at a high cardinality of depth of historical data and a high width with respect to the amount of data you want to compute per proof. And so here's some use cases real quick on these. I don't want to bore everyone, but we've talked about the GameFi application before where you want to search over data to figure out which NFTs are owned by someone. Obviously, that's a perfect example of the type of thing you can now compute with this. You can think about a DAO use case. You're on an L2, and you want to figure out who has engaged in some activity with your contracts to reward them. Differential fees on trading, maybe. Or, for example, figuring out who has voted on your proposals to give them more voting weight in the next one. And next, we can talk about the more interesting DeFi ones, right? Volatility, something that you'll need for Black-Scholes or options pricing, right? You think of, oh, I can get a volatility oracle, but are you trusting the oracle? Are you trusting the data provider? If that goes down, it can potentially compromise hundreds of millions of dollars of assets that your protocol holds. What's the simpler solution, the more secure solution? You specify the computation to drive volatility over the time frame you want, at which point you can then verify the result of that on-chain whenever you need it. And so you might say, well, everyone says zero-knowledge proofs take forever to compute. Why does this giant proof that we're obviously computing not take forever? And this has to do with some interesting properties of our proof construction that make it far more performant at scale. And the property that our proofs have that proofs before us don't have is something called updatability. You can take a proof on overlapping or non-overlapping data, and you can compute over that. And you can derive some proof of some computation, and then you can take a chunk of that proof that you pre-computed from another use case, and you can include that in another proof. And what this allows us to do is to drastically reduce proving time to minimize the latency that is required for these large dynamic proofs. And this allows us to scale proof computation through composition, not recomputation. So if you guys want to learn more, we'll be presenting the paper at Stanford Blockchain this year, or our research team will be. And around that time, we'll be releasing the paper as well as a test net of our construction, the overall proving system, and some of our early use cases. So thank you, everybody. Any questions?
Does anyone have any questions? Yep.
Yeah.
It's interesting from the smart contract point how much it costs to get your proofs and check on chain. For example, especially for your third case, when you talk about aggregating data from different oracles. So how it could cost for real implementation on mainnet, for example?
Yeah. So we are using at the final layer of our proofs a Groth16 snark. And the underlying cost of that is about 230,000 gas right now, which is fixed irrespective of the amount of computation you need. Overall, over time, as on-chain costs and as better precompiles, and so the cost will decrease over time, likely as call data cost decreases as well. But I believe post-protodank sharding, it should be like 70,000 gas. I think the estimates are. But this is for irrespective of computation. So you increase the amount of data you want, you increase the amount of computation you want, the cost stays the same.
Thank you. And yeah, any follow-up questions or any other questions for Ismail?
Come on, guys. Hopefully something technical.
Okay. Yeah, I guess no questions. So thank you again, Ismail.
Well, thank you, everybody.
So give it a moment as they put the sign back up. Okay, and our next speaker is Nick Kunkel from Chronicle Labs, and he will be talking about their new protocol, Chronicle Protocol, Oracle Scalability at the Limit. Nick Kunkel, everyone.
We have a clicker anywhere? Okay. Cool. Thank you. Awesome. So hi, my name is Nicholas Kunkel, and I'm the founder of Chronicle Protocol. Chronicle is essentially an infrastructure company, and we want kind of the crypto ecosystem to stop treating data like a black box and start asking questions about how do we verify the integrity of this kind of data? Where did this data come from? So many of you are probably not familiar with us, but we actually started out as part of the MakerDAO team. So we actually launched the first Oracle on Ethereum back in June of 2017. And we've been effectively securing the entire Maker protocol since then. So there's currently about $9 billion in TVL and MakerDAO that we're securing. And so from that frame of reference, that makes us the second largest Oracle provider in the entire crypto ecosystem right now. So I kind of want to start by just identifying the problem that we're trying to solve. So let's kind of take a sobering look at the Oracle landscape. So right now, when you think of an Oracle, this is probably kind of what you're thinking about, right? You're thinking about, here's some asset pair, here's some price, and great, now you can go read that price. But you don't really have any guarantees here, right? You don't know where did this data come from. Like you essentially don't have like any data availability nor data integrity guarantees. Furthermore, oracles are quite expensive. They're expensive to purchase as a service. They're also expensive to run. The gas cost for running oracles is quite significant. And coupled with the fact that gas prices are highly volatile and can, multiply from what is currently about 20 gwei, and we saw up to like 3,000 gwei, right, in the previous cycle, right? They can multiply to cost into the hundreds, sometimes even millions of dollars a year just in gas costs for a single oracle on Ethereum layer 1. And so this is just completely unviable for anything but like the largest and most wealthy and high revenue generating protocols, right? So what is everyone else supposed to do? So what we've done with Chronicle is we're trying to address 3 distinct challenges. We want data to be verifiable. We want it to be interoperable across any blockchain. And we want it to be scalable. So we want to get the cost per update down so low that we can update much more frequently and therefore have like a much more accurate oracle that relative to its reference. So before I can get a little bit more into the details, I kind of have to give a little bit of context of how Chronicle works. So Chronicle is based on a validator consensus model. And the types of validators that we use are essentially applications in the crypto ecosystem that you're probably used to using every day. And so essentially our trust guarantees come down to, well, if you use MetaMask, you're implicitly trusting in Fura. Right? If you're, you have a mobile phone on your wallet, it's very likely you're using Argent. Right? Maybe you have some open positions on DYDX, right? Maybe you manage your vaults, in Maker and Aave through DeFi Saver. Essentially, we want to get away from, okay, with Chronicle, you're trusting Chronicle, and kind of go towards this like model of if the majority consensus of this community of validators up here tries to launch an Oracle attack, like we have much bigger problems in our industry than just this Oracle attack. So if you look at our front end, this is essentially what it looks like. So you have a bunch of feeds, right? They're pretty much updating usually like multiple times a second. On all of the different data types that we support. Oops, there we go. And essentially what is happening here is they're operating on this kind of like consensus layer. So this other kind of property that we really value is resiliency. And so what we essentially want is that there's no single point of failure or infrastructure that can be taken down, right, and just to take the whole protocol down. So when I talk about this like off-chain kind of consensus layer, what I mean is that we have one layer using libp2p. We have another layer using secure scuttlebutt. We have a third layer using Tor. And of these 3, right, we can even add more in parallel in the future. But of these 3, only one actually has to work for the entire Oracle protocol to function, right? So essentially, these consensus layers are just acting as like coordination mechanisms for attestation kind of aggregation between all of the validators. So now that we have this context, we can kind of go into this verifiable property that we want to go after. Right? So with Chronicle, what we want to get to is you have a credibly neutral Oracle with verifiable data integrity guarantees. So how do we get there? Well, would encourage you to check out our front end again. This is kind of what you would see when you go visit, right? Here's, for example, the ETHUSD Oracle contract, right? You have this number, but what is behind the number? Where did this come from? How did we get here? How did we get to 1,813.50? And so essentially, you can click on any historical price and load up, okay, what were the exact validator responses for this specific price, right? So here we can see, right, that we have the responses that were submitted by all of the different validators. And you can see that Etherscan reported this 1,813.50 number, which, surprise, is the same one that we had before, right? And so this validator was selected because it was the median out of the entire kind of quorum amount of validator set. But we can even go one step further, because rather than just identifying the individual validator responses, we can go and look, well, let's take a look at how did that individual validator construct its price, right? And so you can see that, oh, well, it went to Uniswap v3 and it got this. It went to Kraken and it got this. It went to Gemini and it got that. These are all essentially contained within the stack traces of the signed message attestations. And kind of in the future, the way that you would probably improve upon this is, one, you either want the individual sources to start signing their data, and there are some that are willing to do this, but more than likely a more generalized use case for this is something like TLS, right? So each individual query to each data source, right, has a corresponding TLS proof, right, that verifies that that data was not manipulated in any way. Cool. The other thing you can do is verify that the data that we're showing you in this dashboard is not BS. So you can see the raw signature and then verify it locally in your browser and do essentially what the smart contract itself is doing. So you have this message right here, and you can click verify, and if it's a legitimate message, right, you get this green thing, right, saying that, yep, this validator, right, who was supposed to sign the message, signed the message. On the right side, all we did was we changed the timestamp by 1 second. So this H parameter, right, we tried to verify the message, and it doesn't work. So it's important that, you know, when we say, oh, like these crypto systems are transparent, transparent to who? Right, transparent to some Solidity wizard who's like hacking around on Etherscan and digging around in internal transactions, or transparent to everyone. And so verifiability to me is just this evolution of transparency where it's more accessible to someone like you or me. Okay, and then the last property that I want to talk about is scalability. So scalability is essentially make or break for any Oracle protocol. You can either withstand the gas price volatility that we have in these boom-bust cycles in our industry, or you can't. And so even very, very minor reductions in gas can really, really add up once you start adding these multipliers of, like, you know, 100x gas price, right? 300x gas price. So what we've come up with is essentially an optimistic Schnorr signature aggregation algorithm. And what we essentially saw is that on our current oracles that MakerDAO uses, we saw an immediate 66% gas reduction. So I want to go a little bit more into what our goals were with this solution, what problems we ran into, and kind of like how it ultimately works as a mechanism, and then kind of just run through the numbers. So we wanted one implementation across all chains. This is difficult to do, right? Because on different chains, you're going to have different kinds of characteristics, right? In terms of, oh, compute is very cheap, right? Or call data is very expensive, right? We didn't want to have to support multiple implementations. And that kind of meant that we would have to make some trade-offs, right? So rather than coming up with a solution that's hyper-optimized for one specific chain, we wanted to make a solution that, like, overall was like very good on all chains, rather than just excellent on a single chain. Right. The other thing that we talked about, right, was gas prices, right? We wanted to, you know, the ultimate litmus test is, can we survive a 3,000 GUI like burst? I can tell you that's not a imaginary scenario that has actually happened to us, and it's not very fun when you are literally shoveling hundreds of thousands of dollars of ETH into an oracle that's just getting eaten up, in huge $1,000 chunks. And the other thing we wanted to get away from is you probably noticed earlier in the screenshot, right, the number of validators that we had. So we have 22 validators, and essentially the security of an oracle, if you think of the security as the size of the validator set, is currently directly coupled with the gas costs needed to update an oracle. And that is a really terrible property. You really don't want to make the trade-off of like, well, we would love to have more validators, but it would be too expensive for our business model. And so we're just going to settle for less validators, right? Less security. So a big goal of our implementation was that whatever solution we choose, right, we'll have constant time or near constant time verification. So we can decouple this security from cost kind of trade-off that everyone else seems to be making. Okay, so immediately kind of two problems kind of were in our face that we had to get around. One, I touched on a little bit earlier, right? On Ethereum layer 1, compute is incredibly expensive, and relative to compute, memory is quite cheap. And on layer 2, you have the exact opposite problem, right? Where you have very, very cheap compute, but memory is extremely expensive. And so you would think with these two environments being polar opposites, how do you come up with a single optimized solution for both of these? So that was a bit of a head scratcher for a while. The other thing is this misconception that just because chains are EVM, right, or say they are EVM compatible, there are huge differences between all of these chains that are calling themselves EVM. I think others like to point out, oh, well, we're going to have precompiles that are going to solve this problem, or like call data in the future will be very cheap because we're going to have proto-dank sharding. I have news for you. It's going to take years for precompiles to kind of pollinate from Ethereum out to some of these other applications. And it's not just proto-dank sharding, it's like all this entire bubble of of EIPs that everyone's like, oh yeah, once we have that, everything will be fine. It's going to be a huge, huge rat's nest. And so what we ran into right away was like, oh, well, you can use this type of mechanism or this type of proof, and there's going to be this precompile that's going to let you verify it super cheaply. Yeah, no, you're not going to be able to launch on every chain in any kind of timely manner that's relevant for kind of taking over your vertical. So essentially, that really limited the type of mechanisms that we could use. So enough complaining about stuff. Like, what did we come up with, and how does it work, and why is it awesome? So we call this an optimistic Schnorr algorithm. If you're not familiar with Schnorr, Schnorr is a signature aggregation scheme, similar to how BLS is a kind of a signature aggregation scheme. Ethereum does have precompiles for verifying BLS, but it's for a version of BLS that is super, super unsecure, and so it's totally unusable. There is a mythical precompile coming that will one day let you verify in a very efficient manner the actually secure version of BLS. Yeah, maybe one day, who knows? But with Schnorr, you can actually verify it in much more effectively than BLS on chain at the moment. And Schnorr has been used in Bitcoin quite extensively for a number of years now, and so it's fairly battle tested. And so what we have our validators do is essentially sign and create this aggregated Schnorr signature, right? So now you have one single signature, and then what we have is one validator essentially signing the correctness of that Schnorr signature. And why do we do that? It's going to be, we're going to get to that in a second. A relay, which is a permissionless kind of function. Anyone can do it. You can even go in our dashboard and click an update button and run the update yourself. This payload is going to contain the Schnorr signature, the single ECDSA signature that the one validator did, whatever the data payload is, which in the previous example was a price, and the timestamp. And so what does the Oracle do? Well, the Oracle smart contract is going to, one, verify that the relayer passed a signature that corresponds to the payload. It's going to verify that the signer of that signature, right, is actually supposed to be a validator, and it's going to verify, right, that the timestamp is relatively recent. And so what happens then is we say that, great, this price is the optimistic price. So notice that we did not verify the Schnorr signature here. All we did was verify one ECDSA signature, and so we've not actually proven that the Schnorr signature. And the reason that we do that, right, is to get these gas savings as low as possible. And so instead, you have this optimistic model where there is essentially a challenge period during which this optimistic price can be challenged. And running calling the challenge function, all it does is actually verify the Schnorr signature itself. And so verification of the Schnorr signature is about, I want to say 150,000 gas. So it's still relatively affordable. And if you run the challenge successfully, what happens? Well, that means that the one validator that attested to the Schnorr signature, that they lied, that they're malicious. So the first thing you do is just ban them and remove them from the validator set. The second thing you do is you drop the optimistic price. And the third thing you do is you let the challenger claim all of the ETH that's in the Oracle contract as a reward. And now you go in the Flashbots Discord and you tell all of the people running these Flashbot kind of searchers that here is a really good opportunity for you to make a lot of money. So just always, whenever you're building whenever you're searching for opportunities, just here's a list of Oracle contracts. See if you can call challenge successfully, and if you can, right, you can claim a boatload of ETH. So realize I'm running a little on time here, but this is my last slide. How does this look like from the numbers? So currently, I have on the right, I have the new optimistic Schnorr algorithm, and on the left, I have kind of your standard ECDSA signature verification, right? As if you were to validate all of the signatures. The gas on the left side is using 13 validators, right? So verifying 13 signatures, right? If you were to use double the amount of signatures, right, it would cost a boatload more gas than this, right? If you used less validators, it would cost less. But what you're really looking at here is the relative gas amounts, right? So on layer 1, between the two implementations, we're seeing a greater than 50% improvement. And on layer 2, we're seeing an even larger improvement. We're seeing about a 66% improvement. And once pro-dank sharding is introduced, the call data, cost goes even lower. And so on L2, right, we would expect that 66% number to rise. If you want to put these in a frame of reference to other Oracle providers, Chainlink Oracle update on Ethereum mainnet is between 320 and 340,000 gas. So what we've come up with here is really pushing it in terms of how much lower can you get the gas cost per update. Anyways, so we're essentially ready to launch this. So we're really looking forward to September when we finally get to open it up to everyone. And if you want to find out more, if you want to integrate with us, if you just want to talk, you can follow us on Twitter at Chronicle Labs, or get in touch with me personally on Twitter at Nomos Paradox, and or you can join our Discord at chroniclelabs.org. So thank you very much, and happy to take any questions.
Does anyone? Okay, yes, we do have a question.
Just a quick one. Can we access your dashboard or anything on like non-mainnet right now?
So you can, but it's still in beta. So if you go to chroniclelabs.org/dashboard, you'll see it. But I don't guarantee anything on there until we launch in September.
Okay, thanks.
Cool.
Yeah, sorry, this is a really basic question. I think you explained it and I missed it, but are these validators running a network amongst themselves?
Yep. So essentially they're all connected peer-to-peer. And we have no ability to like say manage that network or shut down that network in any way. So they're using libp2p, secure scuttlebutt, and Tor like all in parallel. Right, so let's say you have a 0-day in Tor and a 0-day in libp2p. Doesn't matter as long as one of the peer-to-peer networks is working. You will still have the Oracle protocol functional.
And again, apologies if you already explained it. How is the aggregate pushed to mainnet?
So that's essentially up to a relayer. So we can use someone like Gelato. Some of our customers like running relayers themselves as like a backup. I think like also incentives work quite well, where you can essentially have people submit like aggregation proofs of like all the gas that they spent and then just offer a premium on gas. Currently, it's I think we run like 3 or 4 relayers. Maker runs like about 3. And then we're working with Gelato to get them spun up on their entire network.
Thanks.
Hey, thanks. Is there any kind of incentivization for the reporters beyond just keeping alive public good?
Yep. So currently they make only like 1,000 DAI a month, which I think is rather low. But that's kind of because we're pre-launch and not making revenue yet on the new oracles. But essentially what we want to do is have the revenue coming in, having like a high double-digit percentage of that rerouted to the validators automatically.
Cool. And is there any kind of commitment and reveal scheme to prevent that they force themselves into the median position or that they manipulate the median by being like inside that threshold, but just pushing above or below by reacting on others' reports?
So I think the way that you combat that, right, is saying that the data sources themselves, right, need to be provably verifiable, right? So we talked about, right, TLS. Or the signing keys, right? So you're not able to like fudge the numbers, right? But you're right that at the moment, the way without those guarantees, right? The validators can report whatever they want, but you're never going to get a majority of validators to collude and be malicious. And as soon as you see like one validator doing this, you just kick them out of the validator set. Cool.
All right, thank you.
Awesome.
Any more burning question? Okay, one more.
Oh, I think I forgot. I was going to ask something about like more your business model and how you plan on approaching people that are using other data feeds, or if you've thought about. Yeah.
So I would say our business model is essentially that we have the largest, the lowest kind of per unit cost in terms of per update cost, which means that we can update much more frequently than any other Oracle provider. And that makes our Oracle much more accurate relative to its reference without having to charge you more. So we can, just, at the beginning, we're really more concerned about growth rather than profit. And so I think rather than saying like, let DeFi live with like really shitty latent oracles and let's make a lot of money or let's make oracles super cheap, I think it's better if we make oracles like a better product first and like actually like be accurate. Because I'm sure you've seen during like drawdowns or during like high volatility moments, right? You'll like look at one price on CoinGecko and then you'll look on chain and be like, why the hell is this Oracle not updating, right? So like oracles have kind of really been like toy products, especially considering how many tens of billions of dollars they're securing, and it can really be much better. So from a business point of view, we're already talking with a lot of people who just can't afford, quite frankly, can't afford oracles anymore, right? It's not a fun VC raising environment right now for most people, and most people are trying to manage their burn and extend their runway. And I think we can offer like a very, very battle-tested solution, right? We already secure billions of dollars in Maker, and they wouldn't be doing that if they weren't entirely sure about our security model. And we can offer something at a very competitive price because of the optimizations that we were able to do.
Okay, thank you everyone, and thank you Nick for that presentation.
Cool.
Okay, and up next we have Mikhail from Gearbox, who will be talking more about exactly how Gearbox Protocol cooks their oracles. Welcome, Mikhail.
Hello to everyone. Thank you for participating, and sorry for my lost voice. I will try to do the best. And today what I really want to tell about, this is yesterday I was in Louvre and it was a really great picture, how to cook oracles. You can see it here. Paris is a really country of the art, and what I really want to talk today, how we cook oracles, but because oracles which we will talk today related to things then we use to compute collateral. For simplicity, Gearbox primarily it's a composable average protocol, so we have a very, very big pain and a very, very significant task for us to check that user have enough collateral. And we do not work only with original tokens like ETH, DAI, and USDC. We usually focus on LP tokens as well. And what I really want to present today, it's our practical way how we cook them. So let's start. And why I'm talking about? So you can see it's the most real Twitter threads. For example, the first one happened 22 hours ago, made it 24 today. It's how Conic protocol was hacked. And it's a problem when people build their own LP oracles as a smart contracts. You should think twice which problems could happen. And Gearbox itself, we have 125 million in November now. It's lower, but still we are quite secure. And what you told the best security practices, what we have not to be in the Twitter of Pexshilting or Sprig. So what's the nightmare about Pride oracles? Why it's so significant for us and why I am not sleep well if I have no proof that oracles work perfectly? You can see a very simple attack. For example, we work with credit accounts, so potential attacker take 850 DAI debt and provide 150 DAI as own funds. So what we have at the account, we have some token A and we have 1000 DAI, which we really believe could be used as 1000 of collateral. Then if someone could pump token A price. It's pretty simple to swap DAI to token A, which is 1-to-1. And if the price is 2, it's quite easier to fool the system and take 500 DAI. So basically you can see on the last slide how attack happens. You can see 500 DAI was withdrawn and the profit is 350. Of course, it's just relative numbers. Of course, they could be much bigger for real case, but it's how it works, this price oracle attack. You pump the price, you fool the system that you have more collateral, and you withdraw real money. And we have like a singleton contract which calls price oracle, and it's a very, very simple way. So you have a token, you call get price, and you get a USD price value as a result. And now let's play a game, because you can see it's quite simple. We use Chainlink aggregator v3 interface, which is the latest one for Chainlink. We take latest round data, and then we get a price. So what do you think about? Could we trust that this part should be work correctly? Because as you know, a lot of people rely on Chainlink, yeah, Aave and other big protocols, or you believe it's not so? Who believes this taking directly price from Chainlink is totally safe and we shouldn't go further? Nobody trusts Chainlink. Okay, cool. I think Sergey Nazarov will be really impressed. Okay, it's true. So we have quite few tests. One was from RiskDAO, who is responsible for GearboxDAO to making risk. And the reason why we should focus was LUSD price. LUSD has a very low liquidity, and it could be really naturally pumped. And as a result, it could be not like 1 USD, it could be like 1.2, 1.5, which could really on a scale become not good for us. And you can see this slide from Yaron. He showed real example how the price going up and down. And if someone could provide real money to pump on real market the price, it could be disaster. And we built a very simple solution, but it works because many complex problems could be solved with a very simple solution. It's not the best, but it works, yeah? So basically what we do, we have a cap for a real stable coin. I think we can agree stable coin could not be 10 and could not be 5. Yeah, it's something malicious and we should not take them. So we make a cap and it's like 1.1 or 1.05. I do not remember correctly. And it works. You can see this price, it's going up. And then we use cap value. And it really prevents from different manipulations of LUSD, because there are some known hacks when you know how people could do that, and there are some unknown hacks. We want to really be safe for these unknown things. Another interesting example, we have a really problem with getting STEs and ES price. And one person was liquidated, and it was like 17 ES liquidation premium, and this person who lost 17 ES was not happy, to be honest. Yeah, because he really have a strategy which could not be broken at any point. And what happens here? Let's check. We use USD oracles, correct? We have ES on the first block, you can see, and we have STEs, and this date was not it was before proof of stake, so STS premium was around 2%, so let's assume that ES for simplicity cost 2,000 and STS cost 1960. At this point, everything is good, but then we get update for ETH USD and the price is pumped up. And you can see, despite Chainlink said that it's like a 2% update, it could be 5 and 10. We make like a data analytics. And in this case, you can see a big gap. So the depth which this guy has an ETH was pumped, and the collateral value was not updated. And the problem here is that he was liquidated, he lost money, and we could not really understand who is responsible for that, because we definitely believe that this approach, we take only USD prices from Chainlink, works well, but STs in this are unsynced, and at this moment, it could be a big deviation. So basically, if you are interested in QR code to my GitHub repo, we make a data analytics, and we found that in 8 blocks, it was more than 5% deviation between ETH price and STEs, which should be. So how we solve that? It's pretty simple. We built a composite oracle. Oh, I think it's missed some formula, but you can see the code here. So we first time take ETH price in USD, then we take the chain oracle price of STEs to ETH, and we compute price. And now they are synced. Now it could not be a big gap between them, which could be very good. The next interesting point is how to build, as I already mentioned, price feed, which based on other smart contracts. For example, very simple way. So we want to understand and evaluate how much could cost Yearn LP token. So we have a underlying price we take from the Chainlink Oracle. Let's assume it's okay at the moment. And we have a price per share, which we take directly from Yearn smart contract. So my usual question, could we yearn for this approach? Could we use this receipt? What do you think? Who really believe that this formula is pretty correct and we can implement it as it shown here? Hands up. No one trusts. Okay, yeah, good. Because as you can see, it's quite fun, but basically the answer here that it's pretty easy to change price per share. Of course, for Gearbox, this cream attack is not applicable. Yeah, it's a very famous attack, but still we have no clear understanding how it could be next time. Yeah, because each things in the smart contract when it works taken on-chain could be a problem. And here also a very simple solution which we use here. So we consider 2 different asymmetric cases. If the price is lower than lower bound, we decided to revert. So this attack vector, when someone could reduce the price and liquidate a lot of credit accounts and get a lot of profits as liquidator. And another solution, then we just cap the upper price. So if you heard about different things happened with curve read-only reentrancy, it's quite difficult to check it because primarily in the smart contract language in Solidity, you have a static call to get price. And the problem here then, during this static call, you could not understand that the curve contract already has a reentrancy flag. It's a private. You could not really understand that your smart contract was called in this receive function from some exploiter attack. And there are 2 possible solutions. You can rewrite your function and make to get price from price oracle as a normal function which could change the state, and it's not a good approach from my point. Or another part, you can also make limits, and if you have a very small window around 2%, it's really economical. There is no economic reason to pump for 2% and move it down. So you can always compute and keep this function read-only, which is really great for integrations and so on. And the last but not least, very good example about how to compute curve stable LP price feed. So basically, one more question. So guys, do you believe? So the initial idea could be like, let's take all balances of this curve LP pool, multiply by prices we took from the Chainlink, and divide by total supply of curve LP token. What do you think? Could we really rely on this approach? So what do you think? Is it a good recipe to make a curve LP oracle? Who believes that it's good? What's wrong? Okay, let's move Forward, yeah, and this is how to manipulate the price. It's a very simple computation. So basically, let's assume in some case, of course, it's also like relative data just to show how it could happen. But it makes a lot of sense if we have one stable coin like USDT, which, for example, could be drawn for 10 cents, of course, as I said. So for majority cases, it means that curve pool will be not like 33, 33, 33. It will be really keep only on this USDT. And if you compute the total value, it will be 12. And when we divide to total supply 13, it will be 0.95, what you can use. But then I can swap one to another and get 45.5 USDC. And in this case, it's a very, very simple manipulation using flash loan, which could give you 4 times more. Because you just keep balances. And it's a very big thing that people sometimes think, okay, we can compute how much money on the contract and it's okay. With DEXs and price impact, it could be a really way how to manipulate Oracle. Then price Oracle attack happened and then the protocol could be racked. Of course, these barriers also works nice, but the better idea which is implemented with us and I think many other protocols, we take minimum price of USDC, USDT and DAI and then multiply it by virtual price to get the price a little bit lower. So we do not provide the exact collateral price. Maybe you can compute off-chain, but it's much safer. So this price computed by this formula could be always a little bit less, but it's a pretty nice for our purposes, and it will never give us a chance to be manipulated and get this price attack. So you can see this implementation. And okay, so we have some collateral. We have maybe very good oracles. Is it enough to sleep well or not? What we should really want to check. One point that I really want to mention here is that we should not trust any ideas about the price. And in many cases, people believe that this price is something that we have like in currency exchange in a bank. Because our first experience, maybe, of course, when crypto becomes like an after mass adoption, that the price exists like you go to the bank and you can find USD to euro price, and it works like one number, yeah? But price is already some aggregated data. And it doesn't mean that you can immediately swap one asset into another using this price data with any liquidity. So to be really ensured that everything works well and you have really ability to not to generate bad debt, you really need to build some price oracle monitoring. And previously I have a big speech about on the DeFi Security Summit, how we built a monitoring system. This is like a short explanation of what we built, that we should measure not only prices, we should understand on any chain how much liquidity we have. And if there is a really normal way to make this exchange without this big price impact. Because the Oracle could say, hey, the price is 10, but if you're going to swap 1 million, the price could be 8. And it's why there is no liquidity there. And we monitor at the moment a lot of stuff in the system. So we monitor liquidity, we monitor all boundaries I told before, we monitor all price changes and so on, to really not to get news from the Twitter and understand what could be potential. So if you're interested in how we work with risk, you can check this riskgearbox.foundation. And here is a real price. So we continuously use different sources of data to understand that what our protocol has at the moment. is really what we can realize in the market. So we compute with Chainlink price or Chainlink base generated, I already mentioned in Yorn and so on, and the prices we have as a spot price using price aggregator, because for us, we have only on-chain operations, and for example, use 1 inch to get these prices is a pretty good idea, or any other aggregator, because you can ask him how we can get, if we swap 1 million USDC or so, get a real on-chain price and compare with it. So basically, that's all. Thanks for your attention. Any questions?
Thank you so much. Does anyone have any questions? You sure? Oh, yeah.
So broadly speaking, how does this type of advancement in pricing make Gearbox a more secure protocol than alternatives?
So basically, it's what I think it's not more secure. I think it's like, I don't know, if you do not want to go to hospital, you should clean your hands, you should wash your hands here. So basically, it requires stuff. But when we go to the monitoring, it's more how we can predict, because basically, Gearbox itself, and unfortunately DeFi itself, we could not rely. Maybe blue chips with and pools with a lot of liquidity could be quite safe. If we can find less of liquidity, some risk committee should make some action before shit happens. Otherwise, it could be a problem. And it could be different things, so we can motivate people to close their position one by one. We can monitor how much credit accounts will be liquidated if the price will be dropped to any value. So we can at least have a clear picture what will be next until it happened. And there are some tooling in Gearbox Risk Framework. We also make some automations which could help people to submit transactions. So basically, the idea here is to get this notification first, then risk committee consider could it be bad consequences, and if so, we should start to motivate people to do any actions. And this motivation could be on-chain. For example, we can change risk parameters to lower some liquidation threshold. We can just write a tweet, hey guys, it's not secure to be in this asset, please do this something, and it also works. So basically a lot of stuff. But when you monitor and have a clear picture what your protocol and see the whole world in the eyes of your protocol, it could be very, very beneficial in terms of preventing some different bad debt when the price could be turmoiled.
That makes total sense. Thank you.
Thank you.
Anyone have any other questions? No? Okay, thank you so much, Miguel.
Thanks so much. Thank you, guys. Okay, everyone. So thank you all for staying here, especially you guys who stayed till the very end of these 2 days. I know some of you have been here since like day one morning. So thank you all. So there are beers waiting for you outside. So there's time for some networking. And you can also quiz fellow speakers if you want during the networking. So thank you all. That's it for BOS23, and see you next year.